Yeah, and my company does here in Connecticut. I study geography.
Can you turn it on?
This one I want to know.
Just check the audio.
Didn't do anything.
What should I do?
Check the audio.
I have to talk.
Yes, please.
Hello, good morning. We will wait some minutes still for people coming and then we will begin our
Okay, perfect.
Sunday.
Hey, check it. Thanks.
So good morning, everyone, and welcome again. Someone is still missing, but we can begin slowly so that they will arrive. An announcement, we are streaming our workshop live on YouTube. You can find the link on the webpage, and in the next week's days, we will also publish the slides and the recording of the workshop yesterday and today, always on the benchmark workshop web page. So always there. So we can. I think we can start in a few minutes, and okay, so we are here. Welcome to the second day of this workshop. Yesterday we had a good day, also some sun making the pictures at the point. And today we will go to the second part of the GeoBIM issue, which is the use case application. So we will see some example of the work that we are doing, that people are doing for using GeoBIM in use cases, in concrete use cases. So tackling different kinds of challenges than just the technical ones. Yesterday we could see the 3D city models presentation, which is one side of GeoBIM. The BIM presentation, which is different for geometry, georeferencing, and semantics. Geometry is more solid. Georeferencing is usually not there, while in a 3D city model is mandatory, and semantics more on the building and less on the city. We also saw the standards which are related to that. So CityGML for 3D city models and ISC. And we saw that some challenges are still there, so we need to harmonize the data. We need to provide georeferencing for BIM. We need to align open standards with development and with their use in data, and to fix some rules to good use the data. And we also need some institutional changes. So all the workflow would change when using GeoBIM for procedures and in institutions. So we still have to tackle some points. This is again the 4 points for which we work for the integration. And today we will try also to tackle the 4th one, so the integration of procedures with stakeholders and how we should exchange our knowledge and our expertise with stakeholders and their knowledge about what is needed and how it is needed for reaching an effective method and an effective use of GeoBIM. After lunch, in the second part of the day, we will see instead some more, again, kind of technical aspects of GeoBIM, which are 2 parts that are essential for integration at a point, because we need to georeference BIM for having it integrated in the right place, of course, in the 3D city model, and conversion procedures. And these are also 2 of the tasks of the benchmark, and some initial results and some procedures will be shown that were submitted. So we can begin with the second day, and Jan Sauter will present the EuroCR GeoBIM project. Thank you for being here again.
Good morning, everybody. For those who do not know me, my name is Jan Stoter, and I'm working in the same 3D information group as Francesca and many of the presenters that we saw yesterday in the Delft University of Technology. I also work for the cadastre. I see some colleagues of the cadastre here in the room. And I also work a few hours in a week for GeoNovum, which is the standardization organization for geoinformation in the Netherlands. And I would like to introduce to you the EuroSDR GeoBIM project, which is, I think, we can see as the initial start of what brought us together here after a few years. As you can see here, it's a collaboration of 12, 13 national mapping agencies. Some of them are here, as well as Swiss Topo, Denmark, Dutch Cadastre. That's Lundjedes University. So universities all here. And that's so from Delft, UCL, Claire. Lund is also here represented. Dublin, I'm not sure if the PhD is here. She was here yesterday. And University of Ljubljana. So let's first say a few words about EuroSDR. EuroSDR stands for Eurospatial Data Research. It's an association since 1953 and brings together NMCA's, National Mapping and Cadastre Agency and academia in Europe. And the aim is to jointly perform applied research to provide educational activities. And it has about 20 member countries. And the members are, both from NMCA's and academia. This project is one of the many projects. So the projects range from data acquisition to the use of open data. But this is one of the many projects that started in 2017. And I think what's very unique in this project is that all these NMAs that we see on the slide came together and they said, well, we want to do something with the integration of Geo and BIM. It is a hot topic in our country. Some countries it was hotter than the others. Some countries already did some more activities on the integration of Geo and BIM and some others did less. But we thought it was very good to collaborate because we learn a lot of international experience. And what is unique in this project is that all the national mapping agencies, they all provided a very small amount of money, which gives us actually money to do, to spend hours on this project. So the correlation started in 2017, and then we had the idea, our aim was to understand the issues that hinder the use of our data, so the data of NMCA's in the BIM domain, and to develop initial solutions accordingly. So it's very fake aim, I mean it's very broad. And that's why we started. We said, well, maybe it's good to start with an inventory about the state of the art of GeoBIM in all our countries, because we have 12 countries in this project, and that's very unique. So we created a questionnaire in the participating countries to assess the current status of use, the awareness, the knowledge, etc., and activities related to the use of integrated geoinformation and BIM. And the aim was to give us the challenges, to give our insight in the challenge that we want to work on in the collaboration. I will not go into the detail in the questionnaire, but you cannot read this, but it says organization level, national level, non-technical, technical. So we addressed all kinds of issues and challenges. And we published a paper on the results of the questionnaire in 2018. It says investigating the state of play of GeoBIM across Europe. So if you want to know the details of the results of this questionnaire, you can read this paper. But the main conclusion was that we see that there is a knowledge gap how geodata is used in the BIM world and vice versa. And that's I think it's a very important conclusion if you want to integrate data from the geo domain and the BIM domain. So a lot of pilots are being carried out, lots of demonstrations are being carried out. But what we see in practice that little knowledge goes from one domain to the other. So most people are expert in one domain, in geo or in BIM, and they have assumptions of the other, or they have ideas how the optimal integration should be. And from that perspective, they build demonstrators and pilots, showcases. But we see in practice that it doesn't really get further. And And from the questionnaire, we saw that this is because there's this knowledge gap. And this is what we wanted to tackle. So how do you do that? So then we discussed quite long on this. So what can we do additional to what is already being done in the world, in our countries, on the integration of Geo and BIM? And then we decided to select one or two workflows from practice where we think that the integration of Geo and BIM information can improve the workflow. We didn't want to do that as a theoretical exercise, like, okay, this is a nice workflow, we think that it can be improved, but we really want to go into practice, to learn from the workflow and to see how geo data and BIM information is used or has potential to be used in this workflow. And the aim of all this is to deliver best practice with data requirements. So what data, what BIM data do you need? What content, what geometry, what levels of detail, etc. in geo applications in this workflow and the other way around. And this is where Francesca started also. She's leading this project. And we identified two workflows. The first of them is the building permission workflow. That starts with the submission of a design to a governmental portal, and then the government decides whether this design is within the regulations of a city. But of course, this process starts much earlier when the architect starts to design, and ideally he or she already has information available on the environment or on the regulations that are valid at that moment, so that he or she can take into account all this context to come with the optimal design, so that when it's submitted to the municipality, that it's not a fight of getting the design approved, but that the design is already according to the regulations as much as possible. So as you can imagine here in this workflow, there are some steps where you have BIM data integrated with geo information that reflects the 3D physical environment, but also the regulations. Well, Francesca started with analyzing the current workflows on the building permission workflow. And it's maybe not surprise for you, but for us it was more or less a surprise, because there have been lots of publications on this. But in all the countries that are in our project, this workflow is, it has a lot of interactive checking in it. So PDFs are submitted to the municipality, and professionals look at the PDFs. So in all those workflows, it's still a lot of interactive checking, which is it's okay if it's objective and if it's quick. But what we see with automation, that it can make the process quicker, because you can do some automated checking. But also what we see is that there are a need to more objective checking, so that all the citizens and all the companies that build constructions are treated, at least they feel treated in a similar way. Also on this part, we already published 2 papers, so for details you can look into those papers, or we can listen to the next presentation after my presentation from Nassim and from the municipality of Rotterdam and Francesca. The second workflow is on asset management, that's led by Claire. And together with Nicola, doing a PhD on this, we were very happy that he entered somewhere in our project, and they will give a presentation about this later on this morning. So we have many meetings with the team, and yeah, I think I can also speak on behalf of the others in the project. All these meetings and all this collaboration, all the mail exchange that we have, all the documents exchange that we have is, it's very valuable, because you really learn a lot about the practice being done in other countries and all the challenges that we face. And also, we are with 12 different countries, but there's a lot of similarities in those the use cases. So that's nice to see, especially if you want to look for solutions. So the project will end next year, and we hope to deliver for those two workflows best practices with data requirements. We also have a project website, so if you want to know more about this project, you can have a look at the website. And that's it for now. Thank you very much for your attention. Do you have those questions? No? Then we continue with the next presentation. That is from Francesca and Hasim. I don't know if I need to introduce you, but maybe I can say that we were very happy that when we started approaching the city of Rotterdam for this project as a use case, that we found someone who is actually checking plans, so that we got to learn about how this workflow works in practice.
Hello. I tend to speak a little softly, so if you can't hear me, please let me know. My name is Hashi Tazardi. I'm from the municipality of Rotterdam. First of all, I would like to say I am not a GeoBIM expert, so don't ask me the hard questions. There's the expert. We will be talking about the GeoBIM for building permission issuing today. I'm working together with Francesca, but actually another colleague of me who is actually working at the department that does the permission issuing, he can't be here today. He is also he's a real expert with respect to permission issuing. Let's see. So, I will start with a little introduction about the Rotterdam Digital City. I will try to keep that short. I work about half my time for the Digital City of Rotterdam. Then Francesca will explain something about, will explain the new workflow for building permission issuing using GeoBIM. Then we will look at investigating regulations, information and next steps. And Francesca will finish the presentation by discussing the data models inspection and then the conclusions and final remarks. And after which we will have some time for questions. So, city of the future, digital city. So we have a social dimension, a social world, and we also have a physical world in each city. Together, this makes up your traditional city. Lately, now we also have a digital world, a new dimension added. Leaning towards the social world, this manifests itself as internet, smartphone, and other social media. However, it hasn't yet manifested itself leading towards the physical world. We believe that is the location at which digital city should be located. And it will also have some effect on the other two dimensions. And we believe that if you can make all three dimensions work together, that's how you will get to a smart and resilient city. In the digital city, we're building a so-called urban platform. We're doing many projects and pilots. And this project, for us, from the point of view of the digital city, is one of the pilots. We're also doing pilots with municipal real estate, pilots for European projects, for example, ruggedized. We're doing energy calculations. That one is interesting because it uses the actual geometry of objects within city models. There's a pilot called Safe Rotterdam in which we compare indoor 3D with outdoor 3D to make a better plan of attack for emergency services. There's a pilot in which we try to build a digital twin, pilot for smart mobility, and social gaming and new shopping. I won't go much into detail because of time. This is an example of the digital twin. We have here underground containers, garbage containers, And you can see that these three are almost empty. This is getting kind of full, and these two are full and need to be picked up. This is a real-time data shown in our 3D city model. You can see bus data. So this bus is late. That's why it's red. You can see traffic data. You can see how fast people are going on the left lane and how slow on the right lane, all in real time. So why is the digital city involved in this project? Because we think that if you have your digital current physical reality in your city model, and you add to that your 3D spatial planning, then you can actually show the allowed new reality that is possible within your city. If you have an initiative, a plan, then you can use this current physical reality to build your plan within that city digitally. We're actually saying the same things, BIM, Geo, and getting it together. Once you have the allowed new reality and the proposed new reality, then you can do your review and validation. And this is for us where this pilot is located. We have another pilot called public participation and objection, but I'm not involved in that. So once there's a review and validation, you can permit it and you will have a future licensed new reality. If you say, no, we won't permit it, we'll go back. But you can also say, we need to change the rules because this plan is so good. And this happens in municipalities. Sometimes we change the rules to make some plans a reality. Once permitted, you need to update your digital twin. Yeah, these are pilots. Thank you. I'll give the word to Francesca.
Thank you, Hasim. So in this framework and together with the USDR GeoBIM project, we made successfully because we wanted to adopt a bottom-up approach in our investigation, and we started interviewing some municipalities, and so we found Rotterdam municipalities really available and happy to provide us data and assistance from nice people. So we began our collaboration, and we are trying to address these 3 points. We want to achieve these 3 points. So a new workflow for using GeoBIM, a way to check regulations in an automatic or at least semi-automatic way, and finally to provide guidelines to designers and 3D city modelers in order for them to understand how to model their products in a suitable way so that they could be effectively checked with the other tools. So first point was the workflow. We began it like 1 year ago, more or less, because it was a long process. And the goal was to pass from the current situation, which is now in Rotterdam, but we could see in the USDR project that is very common in the other countries, and we double check across countries with the other participants, and it's very representative of the current situation. So we want to pass from this kind of linear workflow using 2D products, mainly PDF and sometimes paper, to this more circular GeoBIM workflow, so a workflow using GeoBIM, using 3D information systems instead. So we proposed this workflow starting from the current one, but increasing it and changing it for making it work with GeoBIM. And in the very, very synthesis, it's like this. So we need city regulations in a digital format and a 3D city model. Then we have something that read them as reference for building design. So architect, a tool for architects, or a way for architects to read them as a reference and to understand them for beginning their design and doing their design. Then such a design in BIM should be exported to ISC, validated, and then converted to CDGML. And then all this information should concur in the checking of the regulations to a specific tool. And if everything is fine, it is checked and the building permission is issued and the 3D city model updated. Otherwise, or if some changes happen during the construction, for example, all the process has to be run again, but it should be pretty automatic, so that will be fine. We had this proposal, we had this workflow reviewed many times by participants of the project, by municipalities, operators, and experts. And after that, we arrived, okay, one step more. We also had a look at the procedural workflows because this one was considering the technical steps of our information, so how it is produced and inspected and managed, but we also have to consider all the procedures that are involved in the building permission. So the consultation, the submission, the consultation with neighbors eventually, and so on. So it's also something slightly different but integrated, and they have to go together. So we try to harmonize all of these workflows, also procedurals, across Europe, within the EuroCR GeoBIM project always. And we arrived at an harmonized one that we integrated with our technical one. So this is the final workflow, and we are still reviewing it with municipalities, but usually it's we had positive comments. It is very complex, and it foresees the use of CDGML and ISC data and their integration. So at this point, we can go on and inspect and tackle the specific boxes, which are not straightforward either. So mainly we are tackling ISC validation and to provide some tools, and Thomas that presented yesterday is working on it. And now we will have a look at the regulation checks, which is something even more complex because there is not only one regulation, but a number of departments are involved, there are a number of people and a number of regulations, and we will have a look at it. So these are the regulations that we identified together as the ones having the most advantage from a GeoBIM approach. So zoning and dimensions that have to consider also the context, the parking availability, the impact of the building in the environment and in the city, and the other way around, and then accessibility and structural analysis in some more detail in complex. Now I leave again the word to Hazim, which is more expert than me in regulations, and he's trying to teaching me something.
Right. So like Francesca said, we started by reviewing the current process. Yeah, we can. One of the things that we saw is that 80% of all intakes are faulty. So that's also something to learn. I will come back to that later. We have seen that the administrative, the beginning, is a lot of administrative steps. They only take about 2 days. And in the end, so once the checks are done, you also have 2 to 4 days time needed. Most of the time is spent doing all the checks, 5 to 15 weeks. Which checks are being done? The spatial planning check, also called the admissibility check, so checking with the regulations at that area. And after that, there are 4 very heavy technical checks, and also finally the aesthetics, the architectural aspects are being checked. We did 2 workshops in order to get the main process, and then we did for each of the checks another workshop, so to speak. This is the one for construction. Just like Francesca said, we've seen that everything that is submitted has to be submitted in PDF. In the Netherlands, we actually have a law that states that it has to be in PDF. We looked at what is the basis. Sorry, it's all Dutch. Sorry. We looked at what is the basis for the check. In this case, it's called the bouwbesluit. We have seen that in Rotterdam, there are certain work processes, like if the construction costs more than a certain amount, then a different type of more extensive or less extensive checks are done. There is an intake list in which they use to filter. Yeah, we looked at everything, how many people are working there and what is their, how much information do they have to do their work and can they all do the same work, etc. Um, Now we're busy with the second part of workshops in which we already selected the teams, the regulations which we would like to use in the GeoBIM situation. First of all, we selected Uptown. That's the picture you keep seeing as a BIM, right? But we also thought let's get some more BIMs from the same area with the same regulations, because we would like the results to be how do you say that, replicable. We need to the system should be able to handle different BIMs if it is in the same regulatory area. But unfortunately, we found out that even though this is one spatial planning called Waterstad, this is divided into 4 different sub-plannings called Centrum 1, 2, 3, 4. I can say we did not expect that. And an added complexity is that, it's all Dutch, sorry, that if you build, for example, shops in Centrum 1, you are bounded by a maximum of surface area for shops, but that maximum depends on Centrum 1, 2, and 3. If you're building offices, then it depends on Centrum 1, 2, 3, and 4. So you need to take in account what is built or being built in the other areas adjacent to where you're building. This is the slide for the parking regulations. These are only a few of the tables that are being used. Parking regulations is much more straightforward. Depends on the area in which you're building. If you're building in the center, you need to build more parking spaces. And there are other weighing factors like what's your distance to a station? Are you building offices, shops? Those has an effect on how much parking space you need to realize. This is the last slide for me. So, sorry for the Dutch again. We want to move from this 2D work process in which the first check is done by the municipality towards this 3D work process as proposed by Francesca. And we think that our main advantage in this is that by providing the city model with the rules and regulations, or the geo model, the applicant can do its own first check, meaning that we won't have to spend a lot of time checking all the things that already fit. And we can only focus on those things that don't fit. That was for me.
Okay, so we took those regulations and we tried to use them for GeoBIM, but we had first to tackle some more challenges, also some different challenges, not just technical ones again. So first, human challenge. Regulation interpretation was the first big issue for me. So that text that you could see first in Dutch before, I tried to translate it in English and try to understand it, but I was not able to keep all the meaning. But after I asked some questions. Actually, there was some ambiguity in the text, which is now not called not formal, but is written in a natural language, and it is open many times to different interpretations. And you need to be very expert in the process and in the regulation to understand how to correctly interpret them. So Hazim helped me a lot, and we found the correct person to ask. And with some people, we made this workshop, and we found out a unique way to interpret these regulations. So we finally understood it. And the second workshop was also organized by Hazim in order to involve other experts, not just the Bouwbeslag one, for the building permission. So for fire safety, for structural safety, and so on. Also for the aesthetic of the city, they are all different departments. And in this case, the challenge was at the beginning persuading them of the, of the fact that it was a good idea to introduce a new way to make the checks because they work very well with the
Yeah,
PDFs.
I should add that we are very lucky that this department is willing to work with us, but of course there are also many people that don't really understand the added value of this. I actually got one remark. One person said to me, "Why 3D? I already think in 3D." This was it's very hard to have a comeback for those kinds of remarks.
Yeah, but anyway, Hazim was very good. So at the end of the workshop, we had some input from them, and we will try to follow on this track. So after we clarified some things, we could write the rules in a more formal language, and we try to begin the mapping of the information which is needed to check them to the models that we have in order to understand where to find the correct simulate information and where how to put them together to run the simulation and the check. So at this point, we are ready for beginning the development of the tool that will hopefully make something in automatic, and we just began a project with a more specific one with the municipality of Rotterdam for making it working for next year. So one more part, in order to further connect to the world of practice, we began inspecting a sample of BIM. So we took a sample of models in IFC coming from practice, and we tried to inspect what are the main characteristics of them. We did it through the some available tools, but also in a wide part it was a manual work because no unique tools and completely automatic tools are available for this. And these are more or less the characteristics, the formal characteristics of such sample. So they are mainly ISC2 extreme, apart for the ISC4 that I asked Lorenzo to export for me. Then they use mainly Revit and a few software. And we also had a look at the content of them. So especially we focused on the features that could affect the potential quality of conversions. So for example, the use of ISC spaces, the georeferencing, and how the semantics is managed and stored in the models. And well, you can notice from the green slices of these pies that we still have to work, and the quality of the ISC beams have to increase a little bit more for achieving an automatic work, especially if we consider that these models were very well, probably very good, because even for it coming from practice, they were all part of projects. They were used for projects involving BIM, so probably they were very cared. And also we had a sample of one of them, like 10 of them that were together and were very good. So this is a little biased. So this is what we could see, and this is a beginning. We would like to actually work more on this inspection and on collaboration with practitioners and BIM modelers to understand how we could start in providing also the guidelines for them, and not begin in a completely detached way. So we will look for collaboration in this sense. So some conclusion: it was a complex issue for data, for regulation, for technical and human aspects, and it took a while to set cross-field collaborations in a suitable way. And now we have to tackle all the boxes, all the single boxes which are in those workflow that we could proposed, but we're happy that it found some consensus in the municipalities where we asked to be reviewed. And and we are beginning this project with Rotterdam, and we will have more results next year probably. So thank you for your attention.
Other questions?
Which part of the building permit process do you think gain most from this project?
What part of?
I mean, which part do you think, where is the main advantage? I mean, the building permit is quite
Yeah.
steps.
Well, in the regulation checking, I think we are beginning from the regulation checking because it's more or less the aim of all the process of all which is around. So we will begin from this and the requirement for this, and then we will understand how to fix also the other parts. So the design phase and the regulations, how to store them, and so on.
Clear, Lars? Other question, yeah?
Yes, thank you for the presentation. I have a more formal question.
Yeah.
Regarding your, you have a title where it says that you wanted a bottom-up approach,
Yes.
but you are talking about how the regulations, or from the institution that regulate the construction of the city. So you are talking, if I understand it right, from the top to the down.
Yeah.
How is that you mentioned bottom up and we don't really talk about citizen participation, or how at the end of the question, but the real question is, when you have the feeling that this technicality is going to be more distance, or it's going to build more distance between the public and the citizens and the way the decisions are made?
So that bottom-up approach is because we are from academia, and many words are like very abstract, like in the air. So our bottom-up approach starts from municipalities. So what is needed in the practice of municipalities to make the checks, and what can be useful for them. So we want to develop a conversion procedure and a check procedures following what we think that is useful, or what we found in literature, for example, or from the tools and from the schemas, but we will try to start from the requirements of municipalities. And this is the first step. Now, in our second step, we will also try to go more to the citizens somehow, involving practitioners. So we will also try to connect this work that we are doing with an eye on municipalities. So what is needed in the offices actually for making the checks, and we will also ask designers and architects and people making the checks how that could help them. So, for example, one of the tools that they are always citing that would be interesting and useful, that could be a tool that could understand itself what kind of intervention you are planning and you are designing, and based on this, give you the regulations in automatic. So it's something, it's not the citizens that have to know what a dormer is, for example, the usual example, but it is a system that tells in once the input is okay, I want to build such an object on my roof, and the system says, okay, that is a dormer and you need this regulation for doing it. So that's something to go to our citizens, but yeah, first our bottom-up approach is from municipalities to us, and now we are hoping to add part from practitioners and designers to us.
I would like to add, we are also doing a pilot in Rotterdam for public participation. And we're actually using this kind of technology to to communicate better with the citizen. Because now, in these days, we have information evenings where the citizens are invited, but they are shown 2D pictures and just a lot of paperwork. So we are trying to show them a 3D environment in which we can show them the changes happening. And I believe that these types of technology actually makes it better for the citizen to understand. Yeah.
Another question, yeah?
Yes, when this is all finished, what's the added value?
Would you like to answer?
I think, first of all, in Rotterdam, we have to build a lot of houses. And also our department doing the issuing for permits is very busy. So they need to some way get more efficient, either get bigger or get more efficient. So time is one big issue. We want to spend less time doing the checks.
Also objective.
Another question there?
They were other ideas.
Yeah?
More technical question. You mentioned that you want to store the regulations in some formal language. Do you have already some
We are at, no, we are at the beginning. We began exploring it, and we, like in this project that just started, we will tackle it in a more specific way, and we will decide what is the best way to store them, and if in 3D, if with a spatial extension or not, and so on. Sorry.
Other questions? Yeah, no. There, behind, yeah?
This is coming from my understanding, like, in the whole exercise, did you have any architects on board?
Yep. Couple,
And
yeah.
then when you say that you want to reach the citizen with reference for regulation, that they might be able to understand what sort of regulation they need for their house that
Yeah.
they're trying to build. Doesn't it, like, within Netherlands, because I'm not aware of the scenario how it works here, doesn't it befall on the architect to understand the regulation and design accordingly? Or does it befall on the citizen to decide that?
Well, we have to explain the background probably, because in well, this is not yet part of the project at least, but the issue was that, for example, in the Netherlands, if you want to build something on the roof, I always make this example because I understood it. So if you want to build something on the roof, it's not, there are different definitions and consequently different regulations. So maybe it is a dormer, but for example, if the dormer is in line with the facade, it's no more a dormer, but an extension. And if it is different dimensions, it's something else. So it's really, and sometimes people don't know this, so they develop all the design according to what they think it is.
I
And
must add that, no.
yes, yeah, but the architects themselves sometimes.
No, I think they
Takes
do.
a while.
I think they do.
Shall I add something? I work at the City Council of Amsterdam, and you have to understand, architects are creative people.
Yeah, exactly.
Yes, so they want to make creative things, and their knowledge about the law is not as high as it is for a technical person like me who is working only with the laws. Yes. So sometimes they don't know, sometimes they know, but they want to try to do something different. And then they ask the City Council, can we do this, please? And then you have a commission that is going to assess this, no? So, and many times for technical things, they just don't know. Because it's really a lot.
It's got more complicated than you expected to be, that's for
And the
sure.
architects, they want to be creative, so.
Lars had another question. I saw your hand. Oh.
The architects are not necessarily all the areas, they are very, very
Okay, Lars, you had another question?
Yes, about the detail development plans. Are they machine readable or are they in PDF? How are they stored? I mean, the plans that regulate what is legally allowed to be built.
Yeah, well, at the moment they are natural languages, and then we will explore how to better store that.
To make them spatial, to give them spatial representation.
Yes, if yeah, probably we will prefer a special representation because we like special things. But yes, we will investigate it more like in the I think in the coming months with them. Also. So
The law from January next year will that have to be in a certain way. That really is a prerequisite to go on.
yeah. Yes, of course. I don't know yet the details on this, but yeah.
Are there other
We will
questions?
try to. Something from architects that was
Yeah, so I
comments.
are there architects in the room actually? No. You're,
I'm an architect, yeah. With experience, professional experience. I just wanted to say that architects are creative because markets and clients want this creativity.
Yeah, exactly.
It's their work to be creative.
Yeah, it's not a
it's
critic.
not a bad thing.
Yeah.
It's a good thing.
Cities are democracies because of variety and
Yes.
diversity.
I'm an artist.
Even more crazy.
Yeah, I can imagine.
But maybe also available for the discussion. I know there are most cities here in the room. So I see Amsterdam, Almere, Eindhoven, Vienna, Basel. Yeah, what's that? So I wonder if you think this is something specific for Rotterdam. Do you see similarities, challenges? Any comments?
Same work at Vienna, same challenge
And ideas?
ongoing.
Yeah, okay.
Yeah, in Almere is the same thing. We also try to automate the rules. We actually had a presentation from one of our product deliveries, and which sort of like in the same idea of a rule engine that actually looks at the plans and looks at the ruimtelijkplannen.nl
Yeah.
to abstract the rules and try to get the plan into the fitting regulatory space. And so it looks like it's possible, it's very nearby anyway. So if we look at toepasbare regels, ruimtelijke plannen, it's all Dutch, sorry. But that's Dutch stuff that's already now developing. Which is possible to make the rules more measurable and actually accurate, like it's 3 meters and if it's over then it's too much.
Yeah.
And not, oh, it has to look nice, because nice is not measurable.
Yeah.
So, and that's a way of thinking that the people that now make the regulations aren't used to yet. People are still trying to make it, not as strict as machines need to have it.
Yeah, comment this? I probably agree. We have had this process in Sweden during the last 1 or 2 years, where all the planners had to use a set of rules that were defined by our planning, the national agency for housing and planning. And the argument against it is, of course, that we lose creativity. But the other thing is, of course, that they have this creativity has not really followed the law all the time, because they have inserted things in the plan that is not really regulated by the law. But now they have to follow this list of rules. And that has, I think that it's also a prerequisite that you should go on this approach to transformation. Otherwise, it's not possible.
Okay, thanks. Other remarks?
Yes, I would like to say something, because you were talking about what regulations would be better for this. I think if you are using national or even European, for example, regulations, like for example daylight is national, then economically it's it's more profitable if you make something for this because it's for the whole country. If you do something that is only for Gemeente Almere, yeah, then you have to spend a lot of money only for the houses that will be in Almere. So this is also important aspect.
Yeah, so maybe we should organize specific EuroSDR in the Netherlands. Municipal network. Good point. Other things to add? Oh, okay, then I would like to thank you again.
Thank you.
Like to give you. I want to give you a letter. Sinterklaas letter. And I would like to announce the next presentation from Panacotas. Also from TU Delft. I didn't say it I tried.
Nobody does.
Okay. It's GeoBIM for microclimate simulations, and it's together with Natasha, who's not here.
No, I will talk on behalf of Natasha. Sorry for listening, I guess.
Okay. Hello, everybody. My name is Panagiotis Sarapakis. I graduated from TU Delft from the Geomatics Master. The plan today is to share a presentation with Natasha Mahirden about the GeoBIM for microclimatic simulation. But unfortunately, she couldn't make it, so her mentor Francesca will replace her. We'll take most of the time, around 20 minutes, to provide the introduction to microclimate and give you an overview of my thesis. And by the way, for Francesca to integrate the BIM. So, what's the microclimate? The city climate can be divided and studied into scales, which are of course interrelated. In a mesoscale, the urban morphology affects the weather parameters up to a height above the ground. And one of the most relevant phenomena is the urban heat island effect, which is responsible for the appearance of higher temperatures above the city. But also, in microscale, we have the weather parameter differences in, as you can see here, it's the temperature, but also the wind speed and wind direction, mainly in the urban canopy layer. This is called the microclimate, and this is influenced by building, shadowing, vegetation, and water containers. And if we're able to improve the microclimatic conditions through a necessary bottom-up sustainable design, it is possible that the urban heat island effect can be mitigated. And this is only feasible with microclimatic simulations. Also, access to microclimatic data is necessary since it can be used for accurate calculation of, for example, building energy demand or human thermal comfort. So, a number of microclimatic simulation software have emerged. They have one certain goal, which is to generate detailed weather data, and they differ in the level of simplification of their models, the parameters, the interactions they take into account, the data they produce. And the most complete tools are CitySim Pro and NVMet, which act as a representation of reality. They are really heavy software in terms of simulation time. They can take up to several days or weeks. For example, NVMet, which I used in my thesis, and Natasha is using in hers, takes into account the interaction between many parameters and calculations. It is based on it relies on computation fluid dynamic algorithms for its inputs and output in order to achieve the required output resolution, but also it sacrifices a bit of input quality. NVMet, as other microclimatic simulation software, calculates the effect of the surrounding of the district on the microclimate. So users usually prefer to model the wider area than the area of interest so that they can have more accurate results. NVMet generates a wide number of hourly parameters, which are grouped in folders under some same specifications. It can be either voxel data that describes atmospheric parameter or the soils, and it is in a binary format, but also aggregated data for entities like buildings or trees. These outputs can be read and visualized by a software that's coupled with NVMet, Leonardo. Usually, when somebody wants to construct the required 3D models that this software take as input, is a tricky process and error-prone since it must combine the data from different data sources. But this data is already available thanks to 3D models, which can be either CAD geometries or even better semantic 3D models, which boost the level of automatization since they're created for this kind of application. And in order to see which scale is usable, BIM or 3D GIS, we have to go to an environment scale. So environment voxelized input model is called the area input file, and it is incorporating geometries, information about urban entities like trees, soils, the DM, also water. Currently, the format that is used can be either a simple 2.5D area input file or a full 3D, which differ only on the building level of detail. So in the 2.5D, the buildings are a product of extrusion, while in the 3D, they can have a more detailed geometry, a full detailed geometry, and also detailed material allocation. But since, as I said before, the area input file must be quite large and must include a block or a district, and Environment is a heavy computation software. This model, I would say that it cannot be exploited to its full potential yet, but it's already there. So I would say that the scale of environment is somewhere under city's district, site, and includes a building. And this information are mostly available in a 3D city model like CityGML, with an overlap with BIM as far as the building sector is concerned. But the environment does not allow any information about the building interiors, like rooms or whatever. And here I have the level of details in CityGML for the building thematic module. If we want to design a 2.5D area input file, we have to search in LOD0 if the measured high attribute is available, or in the LOD1. But if we want to go further into the full 3D area input file, we have to look at LOD3 for the geometry, and as far as materials are concerned, into the energy application domain extension, which is a standard for storing energy-related data, and it has a material class related to buildings. So I'm coming straight to my work, where I use the CityGML to assist microclimatic simulations, and I am automatically creating 2.5D area input files. My aim was to establish an automatic data flow between the environment software and CityGML standard, so I can minimize the human intervention in the whole process, and also manage to store microclimatic results back to the city model, so that they are stored as a standard and be reused without having to go through costly iteration every time. And this is my methodology graph. In the beginning, I conducted the data requirement analysis. I checked environment requirements, so if they are available in CityGML, and at the same time with my mentors, we harmonized the existing data into CityGML. Later, I designed and coded a user interface that has two phases. It is bidirectional. In the first phase, it reads data from a 3D model based in CityGML, performs the required operation, which are mostly rasterizations, and converts it to area input file. And after the simulation, it picks data, useful data as defined by the users, and stores them back to the model, to the input model as energy AD data. And this can happen in two ways, either by a geometry matching of the voxel data, if we apply a reverse transformation, like what was used in the first phase, or for the aggregated data, we can match the IPs, which are eventually preserved during the simulations. As a test case, we chose to model an underdevelopment district, L'Oreal in Almere, which is revolving around the prospect of a green village, and it would hold a huge exposition in 2022. So I would say that this was an ideal site. And this is the CityGML model we created, visualized in Google Earth and in GIS. We have what is required for this transformation, which are the buildings, the building module. We fill also the vegetation module as solitary vegetation object, the land use module, and the relief as a theme. So these are environment requirements, and in practice it has only one input file for its simulations, which is a text file, a configuration file that groups together all the real data, which is the voxelized model, the area input file, the weather at the boundaries of the model, some databases that hold information about materials and the type of trees, and some other parameters, user input, like the day of the simulation, the extent, and the roughness value of some facades, etc. So let's focus on the area input file, which can be created in an environment editor which calls spaces. This area input file combines both metadata of the area and urban data, and the metadata is created upon the initialization of the model in spaces. And it contains the location of the model in Earth, information about the grid, the resolution, and the extent, and also an angle towards the north, since we want the axis orientation of the buildings to be aligned with the grid, so that the rasterization are not zigzag. Some georeference metadata aiming at further application, and this is quite interesting because CDGML has georeference data and it can be converted directly. Some default information about the building materials, the concept of nesting grids, which is used to move away the borders of the model from the main features, since the environment is not working properly in the boundaries, and some irrelevant metadata. And as far as urban data is concerned, their input file includes information about the buildings, about the trees, about the soils, and about the DEM. And the data model is a matrix data, since it is practically 2D with a height attribute. Its occurrence is depicted in the matrix in the corresponding position. This occurrence can be either an integer for the height of the buildings, or the ID, which is used to group together columns into single building entities, or a code space linked to the databases for the trees and the soils. So I did the research, and I saw that almost all environment requirements can be met in CTGML if it is ideally if it is extended by energy AD. After some interpretation maybe, but it's there. But in our work, in my work, the weather parameters are left as a user input. The projection system and the location are derived straight from the bounding box. The information about the buildings are derived from the building thematic module, from the LOD0 and the measure height. The two types of trees that are available in EnviMed are taken straight from the solitary vegetation object by the height and the chrome diameter attribute. The soils was the most tricky part, since it can be found in many different thematic modules. And for this reason, we created a high LOD land use thematic module, which we augmented with a generic attribute that describes the material, following the concept of a transportation module. And finally, the DM can be retrieved straight from the relief. So I used the database schema for storing the CTGML data model, 3D CTDB, for accessing and updating data, since all of these things are easy with databases. And here's what the CTGML data look in 3D CTDB. These are the tables, and the interface can search for the specific tables by their name and query the required data and the geometries from the respective tables. And this is where data was stored. In Energy AD class is time series and weather data. The time series is a class that contains the time dimension. It has a beginning timestamp, a step, and the data is stored as a area values. And the weather data is used to associate the time series and the weather attribute to a CTGML class. And I'll present fastly my interface. The aim was to be simple because the user inputs with this methodology are minimum and straightforward, and provide a preview icon. So first, we provide the credential of the database, which is our model, our data. Then the area to be modeled, which is provided by bounding box, coordinates in WGS, and the angle. And the user then can preview and see what is going to be written down before write the area into file. Then information about the grid, the default materials that can be updated if the information is stored in the dataset. And select also the type of the tree between the two options, the single tree or the 3D tree. The single tree is depending on the resolution, and this is something that we don't want, since I wanted the interface to be robust. And I also included a buffered plan, which is a 3D representation of single trees, which is also resolution independent. And finally, the interface in the second phase can read the results straight from their folder and write some save files for visualization. So my results, I succeeded in creating many area input files with the interface that are robust over different resolutions, and also we can read almost any kind of CTGML dataset. Of course, it has to contain the available information if we want it to fully transform into a rich area input file. And also I succeeded in converting the binary format to a point cloud by extracting the centroid of the cells, of the voxels, and apply the reverse transformation, the reverse translation, since this information was stored as metadata in the outputs as well. And with the point cloud, we can easily visualize it into GIS software, and it can be easier, processed way easier. And finally, I was able to store the results into the input dataset. For this purpose, to test the methodology, I did it with the average with the temperature. We aggregated the temperatures into building level, so we can have the average temperature on building. But many other results can be stored back. Of course, they need a different interpolation, and they have to satisfy the class they are going to be stored. So these are the area input files. This is the district in Florida, Southwest, and this is the faculty of architecture in the TU campus. This CTGML dataset only contains the building, that's why it has only the buildings there. And these are some points that were used for the aggregation. We see that with this approach, we return the point cloud to its exact same location, which is really useful. It is geo-referenced. And I selected the first slice of points captured in a building buffer. And one of the implementation quality checks of the interface was to visualize one slice of points into the Leonardo software and my slice from the point cloud. So as you can see, it's the same. And in the framework of the thesis, I ran two test simulation, which is common when somebody conducts microclimatic studies. In the first one, we ran three simulations with the three types, and to assess which type of tree we would use in the last simulations. So these are the three different area input files, and these are visualizations straight from the weather data class of CPGML. And so in the last simulation, we used the 3D trees, which is the most advanced way to use 3D. And after a meeting with the people from the municipality of Almere, we discussed and chose to simulate the cooling effect of the trees in a warm day. So we selected the warmest day of the year, of the last 3 years. And I have some results here that, okay, you can take a look at the microclimate, the different temperatures, and you can clearly see like the wind current, the heat bloom, but this is not the point of today's presentation. So I go straight to the conclusions. I was able to do the mapping and implement the bidirectional interface with access, and it can convert CTGML data automatically to endpoint input. And of course, I was able to retrieve data and most importantly, store it. And I have created a software that can already be used by endpoint users or CTGML and database experts. And as I said before, this methodology is already applicable to other outputs in the same way, like humidity. We can aggregate humidity or wind speed at the building's boundaries. And but more results can be examined and stored back because NVM has many results. And lastly, some limitation in future work. Of course, the interface has to be tested furtherly with more data sets. We should evaluate the mapping of more CTGML classes because for the soils we use the high LOD land use, which probably won't be there. So we need to convert the transportation, water, and greening and vegetation to acquire the soil information. Examine and return more attributes. And finally, and maybe more important, check how to construct the full 3D area file because this is the future. And also prepare automatically the weather files, the required weather data by CTGML Energy AD weather station class. And I will give the stage to Francesca for dive deep into the integration of BIM.
Thank you, Takis. So he made a very good job in integrating 3D city models with MVMet. And I will present now something which is in progress, and it is maybe the results, the ongoing work of the thesis of Natasha, who unfortunately is not here today, so I will have to talk again. So she's trying to understand how to bring this 3D into the MVMet to make the simulations more detailed, and how to incorporate more detail in both in geometry and also in information and in semantics, so materials and material properties and so on, shadows. So we have two alternatives to integrate 3D information. First is to use LV3 and LV4 CTGML models, better with energy ID, and the second is to use the BIM. Usually, we saw that there are not many CTGML models already with the energy IDs for the moment, but when we design a new building, we should have a good BIM, so we will address the integration with BIM, but also with a BIM is not an island usually, so we have to consider both CTGML and IFC in a GeoBIM environment, and then understand how to put all of this in MVMet. So there are many to approach. So first approach is to use the BIM to put it into the CTGML and then using the TACIS procedures. And the second approach is take some information from both and try to put them together in an integrated way in MVMet. And Natasha is investigating which one is better and more effective and easier. We also have a BIM from Floriade, so we are following on the same case study. We have some questions, so what data is needed for microclimate simulation that can be taken from a BIM also. So if there are the ISC entities able to represent this, and also if they are in the models which are modeled actually, what is the level of detail needed? And yeah, okay, this is a very general questions covering all sorts of use cases, so level of detail, of development, of information, and so on. And finally, how to convert it and what geometrical issues can they be. So she began with the mapping of the MVMet entities with the same entities, relative correspondent entities in the IFC schemas, and then she checked if it's existing in the data, and some are there and some are not. And also we saw that, for example, IFC geographic element, which is very useful for representing trees, vegetation, soil, and so on, is only present in IFC4, and we could see from the slides in the previous presentation that we still don't have so many IFC4 models, but there we have probably. And she did the same for both ISC and CTGML. So what is needed in MVMet, what is in the schemas, and what is in the data. And we could see that in the data, something is missing or partial. So again, guidelines will be needed for producing good models for this. Moreover, she tried to understand the attributes which are in the entities. So maybe the entities is there, but it's different for definitions or for the attributes which are contained. And maybe the entity is there, but not the attributes. So she is going into more detail for this. And also looking at the geometry, because we have to choose different, we can choose different resolutions, so the dimension of the voxel and the level of detail of the model that we choose. So if considering the CTGML classification, an LOD1 with different resolutions is like this, and then LOD2 is very different. So we have to choose both of them, and she wants to test how this improvement in the geometry, in the level of detail, can affect the microclimate simulation. So this will be the last phase of her thesis, and to double check that's useful and why to do that, if it is really improving the information that is producing. Yeah. So this is the ongoing work from Natasha, and a similar case, similar issues we could find in an ongoing work from our side, which is the integration of green building XML, GBXML models with IRC. So Anna presented you yesterday the green building standard, which she says she likes because she's not a standard, but okay, it is an industry supported format that works for many energy tools, and it could be nice to understand how the two formats can interact to um, to exchange their the results of the analysis ran with the two kind of models. So we began the matching based on which is always very very tricky because it's not very often a one-to-one mapping, but the same entity can have different names and different definitions. So maybe, well, very often there is an overlapping maybe of the entities, or some parts of them cross, but it's not like, okay, this is building and this is building and they are the same, so we just convert them and that's it. So that will be very tricky to go on this. And also we looking at the attributes in the same entities, but we have to consider for an entity in GeoBIM many entities from the very complex IFC models, and still some of them are not mapped. So we will need to take these from somewhere else in the following work. So it is really an ongoing work, and we will need for sure again guidelines for this, for the architects to put the information we need in the BIM. It seems that we are giving continuously tasks to architect, but from an architect, I'm also architect, so from an architect perspective, I know that many things are needed for when delivering a design. So about the geometrical part, but also the report for statics, the report for energy. So maybe it's more tricky in the beginning, but it's all in the same model. So that could they could give some advantages in the later stages. We will need to investigate more the method to exchange information between different formats. So we need to improve this mapping, because of course it's not one-to-one, and we still need some manual integration in some cases. But once the method will be ready, it will be possible to test very efficiently the impact of design on the environment and without additional effort. So both the architect could test beforehand the performance of the building. So for example, if the installation, the quantity of insulation that they put is sufficient or not. And from the other side, also the municipalities or the ones that are the authorities that need to check this could have advantage of this by automatically check it. And so this is for the moment the early conclusion of Natasha's thesis, which is still going on. And as a conclusion of all our part, TAG is for sure provided a tool for effectively reuse the existing information, and hopefully something from me will also come. And a good integration methodology is critical to achieve an efficient workflow, as long as modeling criteria and requirements that we, of course, need to provide the models in a effective way. And that's it. Yeah, probably we could, in the future, find a way to also store the information and the results of the analysis back to the city model in order to have this information ready to be used for the following analysis. So, thank you for your attention.
Are there any questions? Tom?
the first example that with your done model on you made a functionalized representation of but there's also models that run on the vectors itself. Your LD based on LD1 or sometimes LD0 model. What I noticed is that the representation of the LD1 0 is a perfect footprint from your more complex geometry, which can be actually a very complex footprint. And I know models can correctly deal on even LD0 model, which is a very complex footprint.
Actually, LOD0 can be a very complex footprint.
Yeah.
That's what Tom says, yeah.
Yeah, and in the Floriade CDGML model we created, the models were straight from AutoCAD, so they had the footprints had really many edges.
Sorry, how many?
Many edges. It was not a rectangle or something. Some buildings had like 100 edges. It was like a curve, and yeah, it doesn't matter. When you rasterize it, you have the same result. It's a mathematical process, so you don't care about the footprint.
What was your question?
My question is for other models that cannot be represented by raster proposal, we need the vector.
You mean if we can use more inputs than CDGML?
Yeah, well, if I can.
My point is CityGML can be too easily LD0
Yes.
complex for a model. Is it needed that there's some kind of guideline here how you deal with the LD0 for really simplified models?
So
Well, I think that at the moment they are using actually kind of LD0 for generating the MBMET models because they import the footprints and they give an height to them, and they generate directly the vector, the voxel model like this. So this is what they do at the moment, and it also depends on the grid, on the dimension of the grid that they choose, because they can use a 2 meter voxel, 2 meter for 2 meter, and or bigger or smaller. So this is something that also Natasha would like to test, like how it changes if I change my resolution. So just my resolution with the same LOD, will it? How much will this affect the final results of the simulation? And if I do more with 3D, so with holes and overhanging objects, how it still changes. And so we could also report this to the yes of the representation of 3D city models, that LOD1 can be LOD 1.1, 0.2, 0.3. So there are different variations even in the same LOD. And for sure, it's something very interesting to be tested. And actually, our colleague is now working on the testing of different levels of detail of city models for CFD. So, which is computational fluid dynamics.
But I run some models myself. I noticed that it would be very nice if there's already preset simplified model for running those kind of things.
Yeah.
People often forget that the building footprint is so immensely complicated already. So I agree, it would be nice to have a little bit.
It's not only always a 3D problem, right?
Yeah, no, it's not.
Are there other questions?
Yeah, thank you.
Yeah, Heidi?
You try to convert the model, your 3D city model in a way that it fits the NVMET engine, doesn't it? Is there also a chance that by having more and more 3D data available, that the NVMET model will be changed because you have more details that you could use directly? Because now you're dumbing down, to say it roughly, your 3D model to fit the NV model, but you also could try the other approach, see if the NVMET model could be made more
Advanced.
usable. We have more 3D abilities in it. Did you look into that, or is there any chance of that?
Yes, of course, it is. Yeah. Well, I mean, but there is also a computational issues behind this because now it's slow, but we trust that it will be solved with the time and the evolution. But it's like exactly what they are trying to test. So he developed a very good method to import CGML. And one thing that Natasha would like to do is also to understand how this improvement. So what is the needed level of detail of this information to be in the models? And if we have different level LODs in the same model, it is possible that okay, just the LOD one is sufficient. So we will just take our beam if in the case of the design building, simplify it in the LOD 1.1.2.3 if based on the one that we saw more reliable actually, and we will use the model with the resolution and the detail that better fits also the software performance, I guess, the microclimate simulation performance, because if it's not needed to go for LOD4 and 3 centimeters accuracy, it's not efficient to do it. So
Yeah, I think Infomet updated the area file format to the full 3D like 4 or 5 years ago, so it's developing. And nowadays they're developing tools for reading vector data from OpenStreetMaps or from Rhino, but not from a dataset that combines everything. So the users still have to do a lot of things. But I don't think that they are focusing on changing the raster format to something more advanced recently, since they are developing tools that convert the vector to raster. And the resolution is stable to, I don't know, it is 1 meter or is it 0.5, the lowest resolution, which I think is enough because it requires days or even weeks to run for a global district. It is limited by the computation time.
Okay, thank you very much again. We now will start with the coffee, and I would like to start again at 11 o'clock. So if you can be back here at 11, again, thank you.
Thank you very much.
So would you like to start? You do. Okay, so
Okay.
the coffee break. Okay. Now after resting a little bit with coffee and cookies, we can start again with another use case for GeoBIM, which is the asset management, asset and facility management. It was also started in the EuroSDR GeoBIM project, and then Nicola joined with his very powerful contribution and very important. And so now Claire and Nicola will present you your this use case for GeoBIM.
Thank you, Francesca. So, thanks guys for hanging around for day 2. As I mentioned, this is one of the other use cases that we're looking at under the EuroSDR project. And the first thing we realized when we started looking at both planning and asset management was that we know a little bit about planning within EuroSDR. We know much less about asset management. So coincidentally, Nicola wanted to do a placement at UCL. So I said, okay, let's have some asset management expertise to combine with our geo expertise and develop this use case a bit further. I'm going to focus a little bit today on sort of the practical side of things. Nicola's going to first explain asset management, but let me just give you first a bit of context of where we are. So far, how do we do this? Okay. So far, we've sort of been looking at the identify need planning design in one of the use cases, but also a little bit towards the energy management and climate in the second one. For the asset management, we are over here, the commission to operate, to modify or upgrade cycle of the built environment in a sense. And why this is important in the GeoBIM context, this is the UK number. In the UK in about 2008, they said they could save £2 billion per year by BIMing everything. And part of that calculation is not only the additional communication that BIM brings to construction, but the fact that you have valuable data that, if possible, you can shift over for the full life cycle of an asset. So what we're particularly interested in doing is taking the BIM that's used for construction and design and using it for operations and management. So over to Nicola to explain.
Thanks a lot.
A lot more.
Well, thank you. Thank you, Claire, for the introduction, and Francesca as well for the kind introduction and the invite, of course. So our presentation is structured in this way. So we have 4 main parts. I will speak very briefly about what is asset management, because I assume that probably is a topic not that explored in this place, not yet, hopefully. And then we will go towards the GeoBIM for asset management practical example, GeoBIM challenges and future and wider context. So, what is asset management? Asset management is a discipline you can imagine as the connection between the client or the investment, let's say, and the management of the performances of the building or the asset in this case. So we have 2 definitions. We are more confident usually with the finance definition of asset management. So in this case, we can think about this discipline as the management of clients' investment choices, enabling informed decision during the investment, management, and disinvestment phase. So it's really covering the whole life cycle of the building. Of course, the focus is mainly on the use phase, because that's the longest part of the life cycle and the one where you can achieve and you can create more value. So in this case, asset management usually deals with asset classes like equities, bond, cash equivalents, commodities, and real estate. In this case, the building is just a row on a cash flow. Okay. Well, this is my simplification, of course. If you speak with a financial expert, you won't be very happy about that. But since I'm coming from a construction engineering department, I like the most the technical definition, which is the one on the right. So in engineering, is defined as a coordinated activity of an organization for realizing value from an asset. So in this case, the aim is balancing cost, risk, and opportunities to achieve the organization objectives. So what happens? It happens that in the 90s, mainly in the US, we could say, asset management became a very important, a key organizational topic and discipline to be implemented. And it had been defined, this term, which is engineering asset management, which is a way of, again, managing the physical assets, facilities, and equipments for obtaining a given objective in an organization. And since that moment, we can see that there are many different asset classes that have been managed through this approach, which are public buildings, corporate buildings, infrastructure, military facilities, and urban areas and precincts. So really, both the scale and the definition of the asset can vary a lot. Talking about the definition, we can define the asset in different way according to the objective that we want to achieve. In general, the asset is a physical object which can be used for achieving financial or value within an economic process, business process of a company. So there are some standards that helps us in defining the asset. Okay, the two main standards are the ISO 19650 and the one related to the facility management, which is the second one here. Okay. In this approach, okay, the asset is still defined according to the ISO 55000, which is the main reference standard for procedures in asset management. So the definition is still vague and not precisely located in a specific business process. If we go more in detail, and we look, for instance, at the ISO standard 15686, which is the one which is talking about the life cycle assessment and management of the building, we can see that the asset is defined as a whole building structure, unit of construction work, a system or component or part thereof. So basically everything that is physical inside the building and which can be classified and categorized. Again, going deep in detail, this is the ISC standard, ISC 4. An asset is defined, okay, I will go to the second part, is generally the level of granularity which the maintenance operation are undertaking. So we are getting into this big topic of maintenance management, facility management. I told you that the asset is something that can provide value to a company. So physical assets, now we can speak about digital and physical assets, can be defined according to two types of values. The financial value, okay, which is the one that we are more used to know something about, because it's the one that is usually managed by big asset manager companies, real estate, okay? That's the way in which is defined value. And the capacity value, which is the UK and US approach for the asset management definition, okay? That's the technical, but let's say, way of defining the value of the asset, which comes from here, from the base of this triangle. So it comes from the engineering assets, it comes from the elements of the building, and it's basically the ability of an asset to be used for a specific function. Okay, this kind of definition is more similar to what we adopt, is closer to what we adopt in engineering. Of course, they can't be considered separately, they always need to be matched together, but the focus is more on the capability asset today. So you will never see a presentation on asset management without this circle, okay? Afterward, I will show you a slide on facility management, and there is another very typical way of representing. So this slide is basically saying that we are in a digital built environment, okay? So we have a digital asset which is providing a lot of data to the manager, to the asset manager. We have standards like the ISO 55000, which is providing guidelines for extracting values from the physical assets. And we have another standard, which is other standards. This is one of the main. which is telling us that we need to use digital procedures and approaches for keeping that value, extracting the value during the life cycle of the asset. So this is a very interesting representation of this concept, because we know that building information modeling is usually defined as a way of modeling, keeping the geometrical information attached with semantics, and for keeping, of course, the quality of the information during the life cycle. This representation, which is not even that new, okay, is showing, oh, by the way, Bila Sukar is a big researcher in this topic, is showing how the building information modeling approach, so this way of keeping the information on the physical asset, can be used not only for visual representation, of course, we already know it, because we are talking about this topic since 2 days, but also for make analysis, explore possibilities, so making simulation, detect possible class detection. So we really can use that set of information for a lot of other things more than the modeling, which is useful for decision making. And in asset management, the ISO standard 19650, which comes from the PAS 1192 in the UK, let's say, environment, says that we can create this set of information that we can use for making informed decisions, okay, which is called asset information model, in 2 ways, okay, from existing assets, okay, in this case, or from new assets. So this way of approaching the collection of the information in one repository, okay, in one place where we can take, use it, modify and update the information, is standardized and is provided by a standard which have been published in 2018. So we have no reason why we shouldn't adopt it. That's one. Also because the cost of operation, okay, in particular maintenance management, it had been estimated, this is a US case, so the NIST is a institution working in a construction sector in the US. It had been estimated that the facility managers spend 85% of their budget for retrieving information in the correct format. So we don't still, in this many years ago, we didn't still have a place where to store this information. Today, the situation is not that different, okay? So inside the big topic of the facility management, you can encompass different teams: energy management, financial management. One of the most important is the value management, of course. So how to extract through different scenarios, through different evaluation value from the physical assets. But we can encompass also the facility management, which is the business process which deals mostly on the technical performances of the building. And it is defined by the ISO standard 41011 as an organizational function which integrates people, place, and processes within a built environment with the purpose of improving the quality of life. So this term here, quality in facility management, is quite common. And there are, of course, different ways. Our task is how to define this quality. Again, other definition of the facility management, more and more detail, but in general, it means the management of the building and the system, such as lighting, plumbing, okay? So that really the technical part, the technical management of the physical asset. In this case, the focus is the building, because most of the work has been done on that site. Usually, technical services in facility management are divided in 3 sets. Services in facility management are divided in 3 sets: technical services, space, services to the space, and to the people. So also cleaning, catering, space management, and office layout. Okay, so that's providing a service to the client, to the final user. That's providing quality. I told you that you will never see a presentation on asset management without that 3 circle. You will never see a presentation on facility management without this slide. So if the asset management deals more with the aggregated information that are used for making informed decisions at the strategic level, the facility management has the main objective of providing this kind of things. Okay, of managing the operational services, managing the operational issues and tasks inside or for providing value through the physical assets. Okay, so this is basically the place where we can locate the facility management task. So there is a definition of needs. The facility manager usually takes these needs that are defined by the client or the asset manager, it depends, and develops some procedures for evaluating the quality through the key performance indicators, okay, and deliver services. So what we wanted to do through the integration of facility management at GeoBIM is to understand where this information is located and stored and how it could be assessed and used for making informed decision. Again, this is the level at which we can make decision. We are in this stage. But what we have done is to try to figure out to integrate these two powerful tools for information management, which are GIS and BIM, BIM, with information requirements, okay, that are used for asset managers, okay, for making decision. So it's a kind of filter, okay, that we use, integrated with technical information on the condition inspection and performance of the physical assets. So this is another core function of asset management that can be employed for achieving information on the physical asset. And what we have done is to integrate these two things inside the GeoBIM model, which can provide decision support through visualization, navigation, KPI calculation, and simulation. We almost thought about the visualization and calculation of some simple KPIs, but we are there are ongoing work on something more complex. So just for leaving the floor to Claire, this is this big topic of the digital twin. It's quite controversial. We don't have an answer to this question, okay? But at least we try to overcome some common issues that we have in management of the digital built environment. So the subdivision of indoor-outdoor spaces, which is something that in the case of a public institution or a manager of a large industry park, for instance, it's something that is quite useful because it allows to consider physical assets as entities for providing values and no more like building facilities, outdoor spaces, outdoor facilities. Okay, we collected data in a single source of information for making decision, and we integrated powerful information tools. So we put these sets of information together, and we are trying to investigate also this question. So, second part.
Perfect. Thank you. So to put this in a more practical context, so as you can imagine, there's a lot to learn about asset management, and from the GeoBIM side, we are slowly inching our way towards there. And just like with planning, you've actually got three things that you're trying to integrate. You've got the BIM, the Geo, the assets. You've got the BIM, the Geo, the planning regulations. So there's three things to integrate there. What we wanted to do was try and develop a bit of a practical example and look specifically at something that could occur in practice, which is a sort of handover situation. So you have just purchased, in this case, the Politecnico di Milano, which was our case study. You've just purchased a building, an asset, and you want to do what's called a rapid condition survey to find out what is the condition of what you've got. So how can BIM and Geo, so existing data, be merged in with the condition survey results? So this is our practical test. As Nicola said, it's very much ongoing. I do have a sort of live 3D interactive demo, but just in the interest of time, if you want to see that, come and find me at lunch. So it's common to conduct this rapid condition survey at handover being when you acquire the asset. And for this built environment, so university plus campus, plus the surrounding area, you have a condition survey per room, so you go through and you have a rapid survey that you make on each room. You have a condition survey for the building envelope for the building surroundings, and obviously a condition survey needs to be repeated. So in 6 months' time, maybe they've made changes, so it's a one-to-many situation. So sometimes you have a situation where the condition of something looks great, But actually, when you look at it and you dig in, you find a tiny piece of that room. So the general condition of the room is fantastic, but there's a tiny piece that needs repair. So the data needs to allow for that flexibility as well. And how far in depth you go is obviously a question of time you've got to do the survey and cost of the survey, but also cost of not doing the repair. So that's a particularly cracked window. We have, as Nicola said, three main sources of data for this. We've got the BIM, the GIS, and the asset management data, the AM, FM data. And at this level, we're looking at facility. But then when we start to look at reporting, we can start aggregating up towards the sort of decision-making and asset side of things as well. And we just developed something in open source, Node, Cesium, PostGIS D3, and I will just flick through. There's the QGIS version of the data. As I said, I've got a live demo, but just in the interest of time, because I only have about 10 minutes, I won't do too much of that now. So that is one of the number of the classrooms in PolyMe. Each bench and chair is represented as a point. I will come on to why that is later. So that's still in QGIS. This is now the 3D in Cesium, the same building. You can just about see in red staircases, in blue the windows, and that's the general building representation. That has come from a BIM. So we've got the detail of the model, of the indoor of the building you've acquired, actually directly from the BIM data. And obviously it's GIS, it's databases. You can actually access the attributes, not only the geometry. You can do summary reports, and this is where you sort of say, okay, I've got a database of all the condition surveys that were done across my whole asset. How many of those condition surveys have reported the room to be in poor condition? So then you start to look a little bit more strategically at this asset you have just acquired. How many condition surveys have been done on different things? How many of each object do I have in my inventory? You can start then reporting graphically as well. So we've done some very basic D3 and so on. As I said, there is a live demo if anyone wants to see it. It's not perfect. It's still a work in progress. What's more interesting, I think, for this audience is the challenges we faced when trying to integrate the asset, the GIS, and the BIM into one, in our case, Postgres, but it could be any database. So I just wanted to go over them a little bit systematically, and also from the perspective of me as a geo person, learning a little bit more about how asset managers work and think. So there are things that when you learn about, you say, yeah, that's obvious, but not being in the discipline, you maybe don't know. So we talked a little bit yesterday as well about crossing this disciplinary divide, and this is an example. So we started with Revit 2020 BIM of Building 25 in the University, the Politecnico di Milano, on the campus, created by an MSc student called Hector. Fantastic, really nice.
Big support.
Great guy. So that's the BIM. And what we did, before even exporting it from Revit, we had to create the spaces. So the spaces are kind of the volumes of the room. For us as GeoBIM people, needing a space is something we're aware that we need. Hector, as a BIM person, he wasn't aware or didn't think that you needed the spaces. We had to do that. So that's one already difference in a sense going forwards. And you can get a list of them in, this is in Revit, you can get actually a list of spaces just to check you've done it all correctly. Once we migrated everything through, so the migration process was export to IFC, use FME to do the conversion into, actually it was supposed to be directly into PostGIS, but we found that it didn't work well, so I went FME shapefile PostGIS. That worked. I don't know why, there's an interesting quirk there. The second thing we wanted to look at is, okay, IFC is here, we have the condition survey needs here, this is the items that we need, so those were provided by Nicola. Is there a match? Are there things coming out of the BIM that we directly need for the condition survey? If not, what is the mismatch? And again, this is quite a simple example. So things that already were there that we needed, the doors, the windows, the staircases, great, they were all there. They were called IFC door, IFC window, IFC staircase, and IFC. So you could understand them straight away. That was quite easy. In some cases, things that we needed were there, but were called something that, unless you know what you're doing, you won't necessarily recognize. So I mentioned the spaces. Spaces are actually rooms from an asset management perspective, and actually from a human perspective as well. It's only the technical people that call them spaces. So spaces are rooms. Socket lights, and sockets and lights, so plug socket, light switch, they're called IFC flow terminals. Unless you know, you're never going to guess that one. And a bench or a desk is an IFC furnishing element. So again, just like I said, I wanted to see this as a perspective of somebody learning how to bridge this disciplinary divide. The third one, in some cases we had the geometry, but we had to create it ourselves. So the building is a wall standard case plus the slabs plus the roof. The windows and the doors are provided sort of the opaque facades. So when you're doing the external survey of the building condition, the way the asset manager thinks of it is it's an opaque facade or it's a transparent facade. We use the word door and window. They have their own terminology. So again, it's just this crossing the divide situation. In some cases on the GIS side as well, we needed to create the geometry because it didn't exist in the OpenGIS data for Milan. This was mostly for the outside features. So the indoor features, the BIM was pretty much, it had everything we needed for the condition survey. Not necessarily as we needed it, but we could work with it. It was quite easy to do the 2D creation. It's standard GIS. 3D editing, obviously, in GIS is still, let's say, a work in progress. I think that will be a way to do it. So tools like Revit, like Blender, are designed for 3D object creation. We haven't quite got there yet to that sophistication in most GIS tools. Interesting aside, and this is, again, like I said, it's a work in progress. We had some positional accuracy issues going through, well, it could be in the BIM, it could be most likely FME or cesium tile creator, or even perhaps in just a national grid reference mismatch. So the grey on the, you can see that the shadowy grey is a cesium tile, so it's the raster version, if you wish, the 3D tile of the building. The pink is the vector. They are misaligned, even though they come from exactly the same data source and have been both put through FME. Have to investigate why that is, not sure. And obviously, this is one that was mentioned a few times yesterday. The geometric complexity kills the GIS. There's no other word for it. We have these IFC flow terminals, so the sockets and the plugs, and one flow terminal has 1,084 different points. So you're representing this socket here with 1,000 different points. Just as a comparison, all the roads in our map, so whole of Milan, 12,000 nodes. And again, same problem for the benches. So we had to simplify the geometry before we could really display them in QGIS in particular. And in fact, even trying to display the flow terminals in FME, it was not happy. FME has a data inspector, it was not happy with the sheer volume of geometry we were trying to throw at it. So there you go. That's our points. So the desks, the chairs, the benches, and some of the complex geometry, the flow terminals, we represented them as points in the GIS, which is more than sufficient for what you need for asset management. But if you just want to have a look at it, it's the chair, it's in good condition. You don't really need anything more sophisticated for that. You need to know where it is, which is what this gives you. So that's sort of where we're at now. We've run a mini experiment with 9, 10 students a couple of weeks ago, so we have some data we could start to play with. We start to look at the visualization. Obviously, lots of future challenges to go with this, and we use PostGIS. It worked very nicely for both BIM and GIS data. Compromise is obviously that there's a reduced geometry quality when you're displaying in the GIS. Is that an issue? Possibly not, because you don't maybe need the real geometric accuracy of the engineering drawing of the socket for asset management. The question then arises is, okay, how can you automate that generalization process from complex to less complex? Reporting tools, so the number of condition surveys, but also the average condition of each room, the condition of the building, and the aggregation, that was easy to do. It was easy to connect to Cesium and visualize this data in 3D as well as in 2D. No problems there. We have the data and we can start to think of higher levels. So moving from the facility condition survey up to, as Nicola just explained, sort of the asset manager, the portfolio, the decision maker. And I think, and we're exploring this at the minute, there is a nice aggregation process going on, both geometrically and from facility up to asset. And they are, in my head at least, quite parallel in the sense of you generalize the geometry and it's a facility to asset generalization as well. So that's something to explore. We talked about digital twin, single source of truth. You'll see many different diagrams. This is just one of them. We use PostGIS for this, and we squeezed everything into a particular database structure that worked for us. In future, what you'd really want is some sort of data API, and you'd want to try and leave things in I guess, native format, so that you can get the two-way exchange. We have an extract, transform, load process at the minute, which takes data out of the BIM and puts it into the GIS context, if you wish. What if you want to go two-way? That's probably something that we need to have a look at as well. And obviously, the benefit of doing what we've done, though, putting it all in a database, is that then you can start to integrate all sorts of other different data. On a sort of mix and match approach, this is what I need for this task, so give me this data. Don't give me everything, only give me what I need to do a certain thing. So that's the sort of rough sketch of a future vision, I guess. Okay, so thank you very much. And if anyone would like a demo, come and see me at lunch.
Thank you, Claire and Nicola. So is there any question about this? Yes, please.
I'm a big fan of using database for this kind of data, so I'm really happy you use PostGIS here. I missed the part that you said the disadvantage is that you have reduced complexity or reduced position in the database.
We have not actually, PostGIS didn't give us any problems. The disadvantage is when you come and visualize the complex geometry from BIM in something like QGIS, it's not happy to throw millions and millions and millions of points to represent small features. It's quite easy, and this is in fact what I did, to create a little trigger in the database that will take the complex geometry and just create the centroid point for it for visualization.
Maybe take a whole chair.
Yeah, and just find the centroid and represent it as the centroid. And that is sufficient for the asset manager. What you do is you then have two representations of the same geometry. The ideal would be that you keep the complex chair in the BIM environment, because that's really where it should live. And then you link, but that's a step beyond.
Building on that,
yeah.
Because PostGIS itself isn't GIS as well, can you use more advanced analysis like distance?
Not in this context, but yes, generally very much so. Especially when you're doing some web-based visualizations, I find it's very convenient to do the GIS bits in PostGIS and then just visualize themselves. Yeah. So there are views and triggers, but not so much to it. Yeah.
Yes, please.
You were talking about translating an IFC model to PostGIS.
Yeah.
Right.
Yeah.
Is it as easy as taking a few IFC classes like a furniture class and making it better centroid? Or are there a lot of exceptions for different kinds of furniture that you'd like to use?
It's not easy.
No.
It took a few attempts. In one sense, it was easy because I went IFC, shapefile, shapefile to PostGIS, and to be really specific, I went IFC to shapefile in FME Quick Translate, and then shapefile to PostGIS via the QGIS importer. That's what worked. The geometry in PostGIS is fine. So doing the simplification of the geometry using ST Centroid in PostGIS, no problem at all.
Okay, but you.
But it wasn't straightforward, and there were many attempts to get that working. Yeah.
But the decision to make certain models centroid, is that based on the IFC classes, or is it based on the amount of triangles?
It was based on the amount of triangles that I have in the model, but also on what is useful for the asset manager side of things. Okay. So if Nicola had said to me, Claire, I need to see the chair as a geometry, then I would have had to make a different decision.
Well, yeah, exactly. The point is that there is both a simplification of geometries, importing the complex model from BIM to GIS, but it's also a matter of we need different information for asset management and facility management. So we're more interested in the performance or in the aggregated condition inside the room more than the exact representation of a furniture of a school facility, a university facility.
Yes.
That's
so
why.
Mostly a limitation of Revit, for example, representing geometry like, for example, sweep, and IFC only representing geometry as triangles.
I wouldn't even call it a limitation. I would come back to the point of really it would be nice to keep things in their native environments and somehow connect directly to what you need when you need it. Because for Revit users, it's not a limitation at all. Obviously, they're very happy.
Can you say a bit more about creating the space of each room? Because how did you do that?
Yeah, there is a function in Revit that does it. Basically, you have the floor plan, and you have a. I think I even have it on the slides. It's quite a simple one to do.
We can discuss it afterwards.
Yeah, just very quickly. It works very nicely when you've got nice square rooms, as in not square rooms, but rooms that are vertical and have smooth ceilings. If you've got complex spaces, one of my PhD students, in fact, is looking at doing this through voxelization in transport hubs, where the spaces are not nice and square and extrudable.
Maybe, Lorenzo, do you have something to add on this? Maybe with modeling of spaces. Okay. But sorry, I just add that also for conversions are very important.
Yeah, we knew when we wanted them, but the asset manager who created the BIM expert who created the BIM didn't know that we needed them, so we had to do them.
Yes. Still in the Revit environment.
Yes, exactly. It's analyzed space, and
okay.
You click on the room and it goes and does. But only nicely square, vertical wall, flat ceiling situations at the minute, because Revit they change every year. So.
Next question.
It's been my understanding that the floor area is one of the key factors in facility management. Particularly because not all rooms are vertical walls. There's even a standard for that, and you mentioned one of the parts of those standards, which is 15221, if I'm correct.
Yeah, exactly.
This is in another part of that standard. Is there a specific reason why you left this out?
Well, basically, the way in which you are modeling assets inside a Revit model, it's related on the type of pavements that you are managing. The standard that you mentioned is used mainly for the calculation of the net rentable area, gross areas, which are dimensions that are used for calculating the rent of a building. In this case, we are addressing the technical management of the surfaces, the type of surfaces that we have inside the building. So we may not be yet interested in the value that it has in another discipline, which is in this case the financial way of approaching asset management. But definitely we need to improve this work, and this is a work in progress. So that's a very good.
We have the information in a
we have
sense.
information,
So
exactly.
this is the live demo, and if you click on
a floor, you get, in this case, this is the condition of that room, but we have the floor plans and the floor space in the GIS, so we can do a simple ST area calculation and get the floor space.
From my experience, it's not simple. If you look at the standard, and I have experience with another standard, which is a Dutch one.
Yeah.
It's very complicated when you look at all the rules that apply
That's
to such a
yeah.
calculation
Yeah.
to come to one answer that would be the same for everybody.
Let's put it this way, we have the starting floor geometries. From there, you're, I'm sure, 100% correct, but at least we can start with something physical. Yeah.
Okay, thank you. Any other question? Okay, so thank you very much, Claire and Nicola.
Thank you.
Nicola, I also review your
well.
letter. And now we have another presentation because what? Yeah, Claire, the pointer. You're not liking it. So this presentation is connected to all of these use cases because it deals with a very important issue, which is the keeping the track of the possible changes in buildings and in cities. So city people and also facility people, as Claire also said, have to keep track of the changes, if something is broken and then it's replaced, how it works in our models, and if a new building is destroyed and another built, so how to do that. And so Stelios will suggest a very interesting method to do that. So please.
Thank you. Okay, I will talk about it. First of all, a small comment on the chairs and points thing, because you kind of discussed it. If you think about that, think about the Greek cadastre, it uses points to represent buildings. So I guess a point to represent the chair is not really a big problem. It's not ready yet, so. Anyway, this is a presentation that we discussed with Francesca. The title, Stop Copying Your Files, just as a, it's not really what we see happening. I'm gonna give a bit of motivation, but it's more or less the outcome of a paper that we presented 2 months ago. It's the beginning of the journey, I believe, and in the end I will explain what are the next steps. But basically it's our idea how we can evolve 3D city models to incorporate versioning in it. It's a collaborative work. Mainly it's about my PhD. I'm Stelios Vitalis, by the way, and it's also a collaborative work with Anna Labetsky, General Yohoretu, Hugo Ledoux, and Jantin Stotter. You probably know some of those people. So the motivation is that we work a lot with practitioners. We communicate with them, so we know pretty much what's happening or what they're telling us that it's happening. And what we see mostly happening is that some organizations, municipalities, or cadastral agencies, they tend to come up with this idea that we are going to create the perfect 3D city model, we are going to gather a big budget, we are going to spend it to some company that will create this wonderful 3D city model, and then people are going to work in that. And the first part is working, probably the budget is gathered, it's being spent, the 3D city model is created, and then it kind of dies, as there's no real workflow about how to update it and how to really exchange information and maintain it in the long term. So we have seen that with many organizations that effectively they release it and then 2 or 3 or 5 years later it's not being updated. Simulations might be conducted. Some of the people that conduct the simulations might update it internally, but then it never ends up to the original 3D city model. And this wonderful idea of a city that evolves around the 3D city model always kind of fades out in the long term. And we thought, okay, let's think of an example where this doesn't happen. And as software developers, we have Git or other versioning tools, but Git is probably the most successful one. if you know what it is, you know what Git is or GitHub? Okay, cool. So the idea is, what if we could have that in 3D city models? What if we could keep track of the changes that are happening in the 3D city model? What if we could collaborate and exchange the changes between users? And how would that change the way that we work with 3D city models? Because what happens now is like a 3D city model is being such a precious asset because, of course, big budget is being spent, and then it's so precious and so fragile that we really don't want to touch it, right? It's really important. We put it in a database and we made it as valid as we could and things like that. And the idea is, if we have this freedom of keeping track of the versions and exchanging information, experimenting with that, then effectively in the end, it's more or less that we embrace change. It's like, it's okay if we experiment because I keep track of what I changed. I can go back in time. I can find out where I introduced a validation issue. I can skip some changes that they didn't really work out in the end. Now, one of the common misconceptions I think are not really ideal for this concept is that people tend to think of versioning as the history of a city. It's like we want to keep track of how the city evolves. And that's one portion of the problem. So I want to go back to the definition of what a 3D city model is. So we have the reality, we have the buildings around us. And we have one perception, which is not really a subjective way. We just decide how we are going to model things. We decide a subset of information that we want to keep track. And we model the reality to a 3D city model. So we have some data, which is just the snapshot at this point of what we know or what we care to know at this given moment. Now, this 3D city model only represents that. It might be the case that we want to change the model for two reasons. Either because the reality changed, so maybe this building has changed, or it has been demolished or something. It's quite new, but still. And we want to update the 3D model for that. That's what most people think of versioning, I think. But the second thing is, what if our perception of reality changes? So we just want to acquire more detail. Some kind of new information about this building is now available to us. It is also a new version of the 3D model. And to us, those two changes, they are exactly the same, at least for the context of what I'm going to talk about today. I think if we agree on that, then we kind of simplify the problem. The problem is, when a 3D city model changes, whatever the reason is, whatever the semantics might be, that's always up to the person that updates the model itself. We just want to keep track of what changed. And I hope that's clear. And the idea is as simple as that. We have a 3D city model with 3 buildings, let's say. One of them is being deleted, a new version is created with only the 2 ones. It could be, of course, that all 3 buildings are represented in both versions and just one attribute changed or geometry of one of them changed. It's the same thing for us. Now, whether that happened because the building was demolished or because we don't care about the building anymore, maybe it's outside of the extents of the area anymore or something like that, that's up to the creator of the data to put it inside the 3D city model. Okay? We looked up what else has been done in the context. CityGML has a proposal, and again, to our perception, I think that's the thing that we don't want to do, that it contains this notion of, this is a UML diagram, and it contains this notion of transaction, and every transaction has a transaction value, and it says that a change might happen because it was realized, that it was planned, or things like that. We think those are things that should be inside the 3D city model. It should be semantics of the 3D city model, not of the versioning of the 3D city model. I hope that kind of makes sense. So we came with this simple idea like Git. In Git, you have a repository, you normally check out and you work at a specific folder, you change your files, and when you're ready, you submit back. And our idea is, what if we have a city.json file, because we're working with city.json. I hope you've seen it yesterday. It's like CityGML. So we have a CityJSON file, which is not really a simple CityJSON file. It's a CityJSON file with all the versions ever existing, all the versions of building ever existing, whoever made changes and things like that. And when we want to work with one of those versions, we check it out, and now we have a clean CityJSON, the typical 3D city model that you want of that specific version. We work on that. We make the changes that we want. We change geometry, we change semantics, whatever we want to do. And after we apply those changes, then we commit it back. And now the version CityJSON file has one extra version with the information of who submitted it and a description of what they did. It's as simple as that. If we put that in a data structure, this is pretty much a replication of what Git does internally. We're not using Git, we're just taking the same ideas, and instead of keeping track of files, we are keeping track of city objects, buildings, roads, and stuff. And every version contains a series of changes. Not really important what exact changes. And this was the first version, the second, the third one, and the fourth one. And this is the notion that most people have about versions. That's a linear thing. The arrows are the other way that you might think, because normally we think as time goes forward, but this is how the data structure works. I'm not going to go to the details. I'm going to give you the link to the paper later on, and you can check for yourself. But anyway, normally this is the idea that we have in mind, that, okay, we have versions, and every once in a while we update the model, and this linear evolution happens. But what we learn from Git, also as software developers, compared to other older ones, is that this is not really what's happening. What we want this way of experimenting with our data, and let people work with them freely. So this concept of branching is far more important than just keeping track of a line. Because if we accept that everything should be in one simple branch, simple line of evolution, then again we accept that someone is always in control and will only give us specific permissions to change the model, and again our data is precious and nobody should touch that and stuff. So the idea of having branches is that now we are more free because we can experiment. We can have a master version, master timeline of the evolution of what, for instance, the municipality wants to have as their version of the 3D model, and someone can experiment in their own branch. That could be someone that conducts a simulation. Or in the GeoBIM world, that could be that someone is working on incorporating a new BIM model, for instance, in the 3D model. So I give you this example, let's say. We are at this version, and at this point, a new BIM model is given to us. And of course, it's not trivial to import a BIM model as far as I'm concerned. So we take that, we convert it to IFC, and we import it just as a first version to see what's happening. And that's a new version. It's only in our own branch. We're just experimenting at this point because it might be so messy and so valid and we might want to discard that. Meanwhile, someone else in the municipality actually updates some dates, something that is really important, and we think of it as a maintenance work and updates the master branch. Okay, so the absolute truth of the municipality is there, while we're still experimenting with importing the BIM model. Now we are starting to actually trying to clean up the BIM model, simplify it because we don't really need the internal walls and things like that, or fixed validation issues, and we submit another version with a BIM that now is probably in a state that we want it to be incorporated. And that's how the branches have evolved. And at this point, we can do as we do as software developers when we're developing a new feature. We merge those two, and then, as I said, we were inspired by Git a lot. We pretty much stole the data structure that they have, and we incorporated that in CityJSON for storing that. And of course, in order to achieve what I just explained, we need both the data structure, which I kind of explained, and a piece of software. And the software is much more sophisticated because what's the concept of differences and things like that? It's something much more complicated. We have solved the first part, and now we are working with the second part. So we have a paper which describes this data structure that I said. And we have some software that we're currently developing. Well, I wanted to give also a live demo, but I guess we're running out of time, so it's fine. You can find a command line tool, which is this address, and you can play with that. You can make your own version situations, check out versions, change something, put it back, and things like that. Now we're also in the process of developing a web viewer, more or less like GitHub, something like that, where you can drag and drop your file, your version situation. You can see the list of versions. You can click on them, see the 3D, see what changed, things like that. And yeah, I will finish with a bit of a discussion. So versioning is important because it's like metadata in steroids, let's say. So it's really important, I think, as we allow 3D model to evolve, that we keep track of who changed what and give a brief description of those things. And with versioning, I think we can actually reshape the way we work. If you're working in software development or something similar, and you have actually exploited all the features of Git, I think what you feel mostly is that when you're working such a tool, it's much more easy to experiment, it's much more easy to share, it's much more easy to collaborate. You're not really afraid of messing around with your code, and we think the same should happen with 3D data. And I can give you sort of like a vision. Imagine that one day there is something like GitHub for 3D city models, and municipalities can give the 3D city model like that. And then a person can actually fork the 3D city model. It could be someone that does simulation, or they want to experiment with something, or they want to combine their own data with the data of the municipality. They fork it, so at this point they clone, they have all the replication of that 3D city model, and they start working with doing whatever they want with the 3D city model. And then at some point they think, well, maybe the municipality is interested to incorporate those changes, and they make back a pull request. So it's like, do you want that? Because I took your 3D city model, I conducted this simulation, and now there is some information about noise modeling or whatever. If you want it, you can put it back. So that's the vision, which we think we could allow us to be more open to changes and collaboration overall. And I will leave you with a sort of idea of what we are doing right now. There's a master thesis by a student in the geomatics program of TU Delft, who is working with him in Rotterdam, Konstantinos Mostarakis. And the idea is that he's trying to find stakeholders inside the organizations and convince them to use versioning with citation, and probably for cases like urban planning, architects could, for instance, use branches to experiment with different designs and things like that. We are working to further evolve this command line prototype that I showed you screenshot before, so that you can do all kinds of work. For now, you can only commit new changes. We want to implement things like merging and things like that. And we're also developing a web tool to view and download different versions. And we hope that in a few months, we'll have both the command line and the web interface to be able to do pretty much what you can do with GitHub and Git software. That's it. That's the link of the paper, that's the link of the prototype. And when the web is out, I guess you'll figure it out. If you're really interested, contact me.
Thank you, Stelios. So thank you very much. Is there any question? Yes?
Yes, why didn't you use the normal Git? Is that because you want to add domain knowledge for example, merging geometric objects?
Well, thanks for the question. So that could have been the first idea, but the problem with Git is that Git analyzes a text file, right? And therefore, it's interested in stuff that we are not interested in. We want to keep track of the changes of the city object. But for Git, for instance, if we open a city.json file and only some unnecessary changes happen, like if we exclude all the white spaces or we normalize the JSON. It's the same 3D city model, it's just the final encoding changes. For Git, that would be a change. Or if, for instance, one city object goes from one place to another, which is not really a new 3D city model, it's just a new save of the file, that would be a change. So if you want, the most important thing in order to do merging is actually to have a true diff between two versions, of course. And the original diff that Git does is useless if you think about that. So we would have to build our own tools anyways. So that's why we thought it's better to do it inside synthesis.
Okay, clear. Yes, thank you.
Okay, next one.
Another question, because what you're basically doing with versioning is kind of keeping a ledger, writing changes. And
sorry, what?
What you're basically doing is you're like keeping a ledger with all the changes that have been committed to the 3D model. Before, right?
No, that's not what we are doing. I didn't want to go too deep into the data structure. You can read the paper. But as I said, we do what Git does. Most of the people tend to think that we keep track of the changes, but that we don't do because that would make the whole data structure really fragile. And we want it to be robust. So the truth is, every time a new object changes, we save the new version of the object as an individual object. That might be a waste of space, but there should be ways in the future where we could minimize that by zipping things. That's also what Git does, because otherwise, in order to produce the latest version of your code, or in our case, the latest version of the 3D model, we would have to start from the first version and apply all the changes. So we don't do it as a ledger. Instead, what we do is that for every version, we say, okay, we have like 100 objects. If some of them are already stored, the exact same version, we don't store them again. The new ones, we store them, and then we keep a list of those 100 objects through their IDs.
Thank you. Other questions?
If for example, a dormer is added in version 3, do you plan to highlight that as a change that occurred between version 2 and version 3?
Oh, yeah. Thank you very much. That's something that I would like to talk extensively about, but it's part of the software that I said before. So how should I say? That's part of the diff, right? So you have two versions. You can easily recreate them, and then the comparison is part of the software to be done. That's what Git does as well. Every time it opens the two files and does the diff on the fly. So the question is the software going to be capable to do so? We think there are certain things that we have to solve because they're generic, they apply to everyone. But there are some things that they are generic and they should apply to everyone. But there are some other things that should always go up to the specific implementation. So this notion of highlighting specific changes is also related to whether there are dormers and how exactly we replicate that, right? What's the notion of a dormer? Are we representing dormers as building parts, individual, or as part of a building overall? So because those are decisions that you take when you initially plan how to do your 3D city model, those kinds of things should have to be implemented also at the specific project based on the design decisions of the 3D city model.
That's true, but if I want to use this versioning system, and it will only tell me version 3 is different from version 2, then it's useless. I need to know what changed. That is what Git is offering me in software and in text.
Yes, but even for Git, there are different strategies about creating diffs, actually, and you can implement your own ones. We all mostly use, I think 99% use specific ones, but there are ways to change that. For instance, Git, what it does is exactly what you say that we shouldn't do. Every time you change a line, it doesn't say that you changed the line. It says that you deleted the old line and you added a new one. Even the only thing that you might have done is fix a typo, right? So it's the same with what you say. In our case, the generic solution that we can come up is that a city object has been replaced by another one. And even that could go up to the specific project, because for one project, it might be the notation that two objects in two versions are the same as soon as they have the same ID. But for some other project, it might be the case that I want the system to consider two city objects the same as soon as, for instance, they share the same address, right? So the notion of what two city objects are.
Talking about geometry.
Yeah, but first you have to identify what's the same city object.
Yeah.
Then you can actually compare the geometries. But again, as I'm saying,
You wanted to have versioning on city objects.
yes, at the level of city
As
objects.
you mentioned, instead of files, as GitHub does, you would use city objects.
Yes,
And per object, I would like to see changes.
yes. Yes, but how?
Just as in the example, object number 2 has disappeared.
Yes.
I want also to be able to highlight that the dormer is added, or the part has been demolished, or some other change that affects just part of an object.
But that incorporates some kind of semantics, right?
Yeah.
So the semantics and how you model a
But
doorway.
also geometry.
Well, okay. So is the question then, how do I do a diff of two geometries?
Yeah.
Well, we are not going to touch that, but I guess that should be a PhD on its own, by the way. What we care about at this point is that we have two lists of city objects, and we want to give some basic notation about how we connect them. So
I think that this would be fundamental to implementing this in the real world.
but then how should I show the specific geometry changes? What do you
The
expect?
first geometry identifies a space, and the second geometry identifies a different space. And I would like to be able to see the differences between those spaces.
Yeah, but that's a problem of the viewer. It's not the problem of the data structure or the software that does. I mean, in Git,
It
it's
all
pretty trivial
originates-
because it's just a list of lines and you can see it through a command line interface or a single page, right? And you can see this
based
line.
on comparing two 3D geometries. I would like to be able to see the differences between those two geometries.
Yes, but
And then I
again,
can see what changed in the real world.
yes, but again, you have to see it through a 3D viewer, right?
Yeah, but you have to give that viewer some input.
No, the input for the viewer would have been two different geometries. So there should be some piece of software that does the comparison, and then some piece of software that out of the outcome of this comparison is going to view that in a 3D viewer. And in fact, the form of the output of the intermediate software should be related to the form of the input of the viewer. So this goes up to 3D representations and user experience and things that are really out of the context of what we're trying to do. We give the data structure where we represent the two geometries, and some things we can do, mostly in semantics, and some things we can't, and they go up to implementation or software. Easy to use software in this case? Because from my experience, what you
We should discuss this.
we could, yeah, we could. But I think it's a quite complicated thing, and basically,
Oh, yeah.
we're not we are not going to work on that, but or maybe at least we can only identify if something exists in both versions or not, and then some basic rules about comparing the things that change, that actually only exist in one version and another. We should find ways to link them. Does that make sense? It's the same as we do when.
Wondering how you want to implement merge if you're not comparing geometries, but like I said, maybe we should discuss this over lunch.
Oh, actually, that's an interesting point. That's exactly why we don't have a nature file.
Okay, thank you. So we ran a bit out of time, so
Oh, by the way, we have citations ticket for
yeah. Everyone who was convinced by these very good presentations of CityJSON, CityJSON stickers will be available for everyone, so please come and take. And yeah, we can go for lunch and maybe having more discussions during lunch and after the workshop in the afternoon about this and other stuff. And so we can come back at 1 and have a good lunch.
So,
It's just walking around.
Okay, so welcome back from lunch, from the very good lunch. We can start our afternoon session now. If you're ready. A little more forward. They're having fun. It's good.
Yeah.
Okay, guys, so welcome back again. Now we begin our afternoon session with Lars that will explain us about the options for georeferencing ISC, so something about georeferencing and something about the answer to the task 2 of our benchmark. So please, Lars, to you on stage.
Yeah, thank you, Francesca. So what I will do is that I will go through this test bench task 2. But before that, I will talk about a few other things. I will start by providing a crash course in 5 to 10 minutes about basic geodesy, and that is especially for those of you who do not have a background in GIS or in geodata, so that you could understand what's the problem with the georeferencing is. So then I'll talk about coordinate system, both in BIM data and also a bit about how that is solved in IFC files. And when you have stored information, then of course you need some techniques for georeferencing that I will shortly describe. And I will also give a few words about georeferencing in the BIM program, very shortly. And in the end, it's the test bench. What I will not do is talk much about the details about the programs. Following my presentation, there are 3 other presentations that are more demo sessions where they will go through how georeferencing is solved in practice in 3 different programs. But starting with coordinate system used for geographic data. And first, an observation. The Earth is almost a sphere, but not a perfect sphere. In here you could see the perfect sphere, and if you have very good eyes, you could see that there is a dashed line, and that's the actual shape of the Earth. And that describes the most common used ellipsoid, the GRS 80 ellipsoid. So, but often when we describe the shape of the Earth, we are exaggerating the flattening with that we compress the Earth like this. And we are using different types of parameters then to describe the shape of this so-called Earth model. And the Earth model that is used today is the ellipsoid, and it's described by 2 axes, the A-axis and the B-axis, where the B is a bit shorter. The main point here is really how you describe the position of the ellipsoid. And this is described normally by 2 parameters, the longitude and the latitude. That is, of course, not the news, but the main point here, I guess, is that when you're talking about longitude and latitude, you do not really measure that in accordance to the Earth, but to the Earth model. So how you place the Earth model in relation to the Earth, then you get different latitude and longitude values. So it's important to notice that latitude and longitude are not absolute things, but rather relative things. But normally it's
quite difficult to deal with latitude and longitude, and you want to have a planar coordinate system, because that is easier, for example, if you want to have a background for creating a building or something. So in a simple way could be just to create a two-dimensional coordinate system based on latitude and longitude. And this is an example of a map of Sweden where we have done that, using longitude and x-axis and latitude on the y-axis. That would be possible, but the map is not really good. So especially if you're coming up to the northern latitude, you have to separate the meridians more, which makes that the map is very much distorted. So the problem is actually impossible to solve very good, because you cannot really map a curved surface on a planar surface without any type of distortion. And there are, of course, mathematical proofs of that, but you could just simply think of a practical case where you pile an orange and you try to put the orange out on a planar surface. And then, of course, you have to stretch it or do something. So we need to do some type of distortions. The type of distortion that is done in most coordinate systems that are used for practical handling in municipalities and so on is the so-called conformal map creations. And in this case, you make a change of scale in the map. So you have one scale here and another scale on another place. But the good thing with this is that you keep the shape and the angles overall. So a sphere is always mapped to a sphere, but at some places on the map it's smaller and other places it's larger. The other type of map projection that is normally used is the so-called equal area projection. And in this case, you maintain the area in different regions, but the shape will change. And in here you could see that Africa is really, really large, but often we see it in this way when we think that Africa is small. So if you're looking into the different types of map reactions, they have different usage, and there are also recommendations from, for example, Inspire of what type of map reaction you should use for certain purposes. And for certain analysis, you use area preserving projections. But in the case where we are working in municipalities and in a smaller scale, the smaller areas, then we use the so-called conformal projections. And the example that has been mainly used in the test bench is the transverse Mercator. And this is a type of map projection that is much used both on national level and on city level. And it's also then recommended by the Inspire. So if you look at the transverse Mercator, it's a lying cylinder like this that touches the Earth along one meridian. And if you do that, you will get a projection that has a very good mapping along the central meridian here. But then you get the scale error, and the scale error is dependent on how far you are from this central meridian. So if you're far away, you get a larger error. And just shortly also about the height. The height system that are used normally in municipalities is based on the orthometric heights, and these are measured based on the geoid. And the geoid could, in popular terms, be seen as the ocean's prolongation under the land. The important thing to notice here is that this height is not completely orthogonal to the map projection plane. So we don't have a true three-dimensional system in for geographic data. And then, of course, I said earlier that the latitude and longitude and all map projection coordinates and so on, they are measured based on the placement of the ellipsoid to the Earth. So this means that we need to have some kind of agreement on how this ellipsoid should be placed, and that agreement is really different type of geodetic reference systems. And the main reference system is the ITRF system, and that's a scientific system. Based on that, we have a number of systems that are used in more practical usages. We have VGS84 that is used for GPS. One problem with VGS84 from our perspective is that it's updated roughly once per year, depending on that the Earth is changing all the time, tectonics and such things. But that's even worse here for ITRF, that is updated roughly once per month or so. This is of course not practical. We cannot update our coordinates so often. So in Europe, we have decided that we should have a common solution, also based on ITRF, that is called ETRS89. And then all member states of the European Union are obliged to have their own implementation of ETRS89. And this means that all coordinate systems in Europe should be consistent on centimeter level, while we are not consistent to the rest of the world on that level. But within Europe, we have a quite good system. If we look at the example of Møderan, which was one of the test objects in this case, it has this reference system SVEREF 99, which is a Swedish implementation then of this European system. It has the map projection, transverse Mercator with a number of parameters. We're skipping the details here. And this coordinate system is called SVEREF 99 1545. And it also has the so-called EPSG code. And this code is important because in some GIS program and also BIM program, you are using this code. And in EPSG code, it's simply a list where you have listed all important coordinate systems. So they have a unique identifier. And this unique identifier both describes what type of reference system we have and which map projection you are using and which parameters. So by just adding this here, you are actually telling everything about it. And for the height system, in this case, it's also orthometric heights called RH2000. So now we are switching and say a few words about coordinate system used for BIM data. And this is in a way simpler because here we are using traditional engineering system. It's a three-dimensional coordinate system where it's actually truly orthogonal axes. Here you are making the assumption that the Earth is flat and also that the scale is constant everywhere within the model. And also that the Z axis then is perpendicular to the XY plane. So if we have a look at how we could provide georeferencing information within IFC, in not the first version, but Helga was describing IFC yesterday, and she said that one version that was actually a few years old, but still much in use, was IFC 2.3. And in there is an element called IFC site. And under that, there are some attributes called ref latitude and ref longitude, as well as height. And these values provide latitude and longitude information in VGS 84. So if you go and download the file from the test bench, you could see here that there is on one row georeferencing should only be used for approximate georeferencing. So you should never use it for sub-meter referencing. One reason is that VDS84 is not defined better than 1 meter in Europe, because there is no real marker on the ground that says the coordinate values in VDS84. And we also said that they are changing roundly once per year, these coordinates. So that means that you should use these for approximate things. It works very fine. But if you need more accurate things, you should use other possibilities. And one possibility that I didn't know earlier was an ad hoc solution that was actually used quite much in BIM programs. And for that, they are using some kind of shifting in IFC. And so you add some kind of shift parameters. But this is not an official way of doing it in IFC, but many programs actually do this anyway. So it's a kind of informal agreement to do this. But in IFC4, there is another model that is more the formal way of using it. And then it is to use the IFC map conversion element. And in that, you could add easting and northing, the height, the scale. One thing here to note is really what does this scale parameters say? And while reading the IFC document, I have not been able to figure out what they mean. We said that there is one scale differences in the planar system, and there should be another one in a height system, for example, but that is not really provided in IFC. And then there is two, namely x-axis abscissa and x-axis ordinate that describe how you are going around the z-axis. So that's the more the direction of the coordinate system. And there is also one element called IFC project CRS, and in that you provide this EPSB code for the coordinate system. So in here you could actually describe which coordinate system you're using, and you could provide all systems that has an EPSB code. And so I think that all city systems in Europe, for example, they should have an EPSB code, which means that for us working in this community, it should never be a problem to find our system, and we could also here fill in the coordinates accurately for performing real georeferencing. So if we have a look at one program, and this is shortly, I'm sorry. Now we just have a look at how we could then transform, if we know the coordinates from the IFC file, how could we utilize that for georeferencing a model? So now imagine that we have a BIM model here that is given in this local system, that is the BIM system. And for this IFC file, we know the coordinates of this one, and then we could perform some kind of transformation. And a simple way of doing this is to use some kind of three-dimensional similarity systems. And in this case, what we do is that we rotate the system with this rotation matrix. We have a scalar factor, and then we have a translation that moves the coordinates. An important thing to note here is that the scaling factor is in this case the same in the planar system and in height, which might be a problem sometimes. And also in most cases, actually you're not allowed to do any scale changes at all because it's preset to 1.0. And the rotation, normally in this case, we only allow rotation around the z-axis. So some shortcomings of this approach is that we have one scale differences in the planar coordinates x and y, depending on where we are. If we are from this meridian, we get the scale error in the plane, but not in the height. So in that case, you should separate perhaps the height from the planar when you do the transformation. And it's also assuming that the h-axis is perpendicular to the NE plane, which is obviously not. But this effect is quite small, so often you could neglect that one. One effect of transforming a BIM model to GIS model or geodetic system is as follows. Since this is a map in a three-dimensional Cartesian system that doesn't consider the shape of the Earth, you get the effect if you have a very large BIM model that what is up here. Because here, if you think that this is up, it could be a facade. It's not really up in when you do the transformation, if you want to have this as a rigid object. So this means that a facade will start to lean like this, if you want to keep this model rigid. And for a building, this is very small, so it's nothing you really have to consider. But if you're working on the infrastructure side with large BIM models of a railway or something, this is a noticeable effect that you have to take into account. There are different ways you could consider this. First, just taking some here. If I don't consider this effect, but rather keep everything straight, then I get some errors here in the transformation from the BIM model to the geodetic system. And this error I get here is dependent on the map projection. But I could make another type of transformation. And in that case, I guarantee that all facades of buildings or other things that is really like this in the BIM model will also be perfectly along the plumb line in the GIS system. If I do that, then I will get some other larger errors in the transformation. But on the other hand, I get the good things that up is always up. So it's always a balance between what type of purpose you have. I haven't gone into details here, but if you're interested, there is a good article that describes this very well by Uggla and Hormus. Now I'll switch a bit and say a few words about georeferencing in Revit. The very simple type of georeferencing you could do in a menu like this, and here you could simply click on a map, and that will give you an approximate position of your model. This is fine for many applications. You might be just interested in the rough position of your BIM model, depending that you will do a solar analysis or whatever. But this should never be used for more accurate positions. Then you have to fill in values in something called the survey points or project-based points and so on. And Claire will show that in real soon. So I don't put details here, but I could say a few words about what type of coordinate systems that are used in constructions in Revit. Many people prefer to use the internal coordinate system, and that is also recommended, and this is often aligned with the building. So imagine that you will do a model with a building like this, you might align the coordinate system like that, and you do all the work here. But if you want to share and combine buildings, say for example that there are 3 or 4 buildings in a neighborhood, and you want to see these at the same time, then you cannot work only with the internal coordinate system. So one could think about, well, you should use a real geodetic reference system. In Revit here, denoted a project coordinate system. One disadvantage of using that is that you will get really large numbers here, and that will especially affect the graphics within Revit. So it's not really recommended to work with that. But there is also one other system you could use, the so-called shared coordinate system. That is something in between. It's aligned with the geodetic reference systems, but it's already go here. It's moved to a place that is close to the area of interest, which makes that the coordinates is smaller. So, and then you could use that for sharing, for combining different type of models. So the final thing that I will describe deals with the result of the test bench, and this is task 2. And this was made for describing available georeference procedure for IFC inside and outside BIM software. And there were a number of questions in this task. So for example, how long does it take approximately to zoom, pan, rotate, query, inspect, analyze, and edit the model using an ungeoreferenced model? And then the same question were asked when we have georeferenced the model to see if there were any differences in handling this. And then another question was, are georeferencing tools available in the standard version of the software, or are specific extensions or plugins required? And another thing was, is it possible then to describe the coordinate reference system, and are there any specific features for this? And are there a list of all geographical or projected coordinate reference system, or could, for example, all systems that has an EPS code be supported by the program? And also a final question was here about the georeferencing process. So were you able to move the model to a certain place? And also, were you able to rotate the model? And for this task, 3 different IFC models were used. It was Myra, Uptown, and Savillon. And the softwares that were tested here was ArcGIS Pro, and there were 2 3D viewers for BIMs. It was EVBIM and FZK viewer. There was 1 extract, transform, load program, and that was FME. And there was a specific program for IFC georeferencing called EU Ref Checker. And finally, Revit was also tested. And this demo session that will follow will describe FME, ERC Ref Checker, and Revit in more detail. What I will do now is just to describe shortly about the findings here. You can also say that there were quite few persons that made this task. It's actually 1 per program, so not so many as for the import and import of IFC and CTGML that was tested yesterday. And it was also so that some of the person that performed this test were really experts, while some of them were more or less the first time they tested the program. So that means also that the slides that I'm going to show now is based sometimes on person using their programs for the very first time, and you have to consider that when you're looking also into the result. If we take the first one, so that's ArcGIS Pro, it's almost immediate to zoom pan, rotate, and query this, irrespective if you are using standard, I mean, this internal coordinate system, or if you are using a georeference model. And georeferencing tools are also available in standard RPS Pro. But there were some problems here of georeferencing the IFC file. So this user had that problem. But I've heard from other ones that it should be, this is possible. So I'm not really 100% sure about this. But there might be some restriction of handling IFC files then inside RPS. Yeah. And then we go to this BIM viewer called GeoBIM. And again, it's almost immediate if you want to zoom, pan, rotate this type of, or any type of model, irrespective if it's georeferenced or not. And there are georeferencing tools within here. And this is one, many of these in French, for those of you are familiar with that. But there was some problem with, yeah. Well, it's also so that for this program, they work natively with IFC file. So it's no problem here to import and export. And for the FME, again, it's very fast to do zooming and panning, irrespective of the model you referenced or not. And well, FME is really a tool for performing different type of transformations. So it's not that surprising that georeferencing is easy in a way to handle in FME as it's available. You could explicitly define the planar system, but not the height system here. And of course, it's possible to rotate your model towards cartographic north. And another BIM viewer is FKZ viewer. So this is a pure viewer. You are not allowed to do any edits, but of course you could rotate and zoom in and out in this model. And for that one, it's really fast as well. What takes a bit of time is the import. So this 5 minutes here should mainly take for import. So it was not possible to rotate the model towards cartographic north, but it was possible to move the model. So it has translation, but not rotation built in. And also this model program gave a lot of error messages. So that was the discussion yesterday when we have which programs that provide error messages. Most of the program just skips them even if there are errors, but this program reports a lot of them. And then we have IFC URF checker. So this program is actually not really for looking at the model as such, and you will describing, and this will be described later on, really what this program performs. But what it does is that it's a specific tool for georeferencing. It's not really for viewing models or editing models and so on. So therefore the questions asked here was not always applicable for this program. And finally, we have Revit, and it's almost immediate to zoom, pan, rotate, and so on, irrespective if the model is georeferenced or not. And there are georeferencing tools available. So we could use these survey points and project base points to georeference a model. it reports some errors here in the import here. Yeah. So, and as part of this, it was possible to rotate the model in towards cartographic north and so on. Now I think my time has run out, and it's time for the demonstration part. And Claire will start describing Revit, and then Henrik will go. I don't know. Have you decided order? You start. So Henrik will start with this ISD ref checker, and you say Järne. Yeah, you will have FME in the end.
Okay, so apologies everyone, I'm going to Revit, FME and Q.
So while
Standing up.
while Claire is fitting, I don't know if there are any questions about the more theoretical part.
I have a question. I'm curious about the difference between the old version of IFC and the new version.
Yes.
So you said now, if I understand correctly, we can use actually the local coordinate system and the IFC site class.
Yes, it's within IFC this possibility exists, but I have never seen a program that is utilizing this. And we tried a bit with Revit yesterday, and they were not able to export using this IFC things on this IFC map conversion. So I'm not really sure about the support, and I'm not really sure about whether it's a part of this, what is it called, the reference model. It's called like that, the IFC. Helga, you have to help me. The reference is here, or there is something called IFC reference view, I think. Okay. So if this element is part of the reference view, that I'm not really sure about.
But at least it's a step forward. Like now we can use local reference system, and then the softwares can deal with it. Maybe in the future version.
Yes.
Something like this.
And I think this must come from the infrastructure side, because IFC4 is quite much many new features there for handling infrastructures, and for them this type of georeferencing is perhaps more important than for our case. So I think that if you go to the specific software for infrastructures, then they might read and write this. That I don't know, but that's my guess that this is more used there.
Can I ask you another question? You also talked about the rotation about the z-axis.
Yes.
So is it supposed to be the cartographic north? So
Yes.
So the project would be fixed directly rotated.
Yes.
Any other questions for us?
No? Okay, so Claire, I think you can begin.
Excellent. Okay, guys, as I said, apologies for sitting down, but I need to try and drive a few different pieces of software here. I have a demo. I also have backup slides because it's a demo, so it might go very wrong. What I'm going to demo is the very, very basic way to georeference an IFC file in Revit, and then also how to just take that IFC, export it, and put it into QGIS. So just a really quick workflow in the next sort of 20 minutes or so. So the first thing to say, and Lars already said this, is you open, we're going to use the Miran example. If you open the Miran data, Sweden data, come on. My laptop is going to be a bit slow as well because it's got so many things going on there. So if you open the Miran data, it takes, give or take, I don't think, well, 3-4 minutes. And there will be a few errors. Whilst it's importing, so basically I'm taking the IFC and putting it into Revit. Let me show you what happens if you don't georeference things. So this is, zoom in again. This is a data set that's gone through this is Miran that's gone through the workflow of no. Yes. Incompatibility of power supplies. No, it's my laptop has died.
Okay.
That's quite tragic.
Okay.
Yeah, go with the it's true. Either the power's not working down here, or
So should we?
yeah.
So I think that.
Let me see if that works. If that didn't work, we'll move on to the other demo.
Yeah.
That didn't work either.
Maybe we can see
That I didn't predict. Even slides won't save me from this one. Yeah.
You killed it.
I ran Revit, FME, and Q in one go and died.
Yeah, it's right.
Oh, I do have an update.
So maybe in the meantime we can move to the next demonstration and then we come back later.
Yes, I think, apologies guys, I will go and see if I can, it was charging at the back. I don't know if the power is, anyway. Move on to the next demo and I will see what I can do.
So, you want to do that?
This is a interoperability failure. UK plug. The next demo and I will see what I can do.
So, you want to do that?
This is a interoperability failure. UK plug. Still in socket. Sorry guys.
Is it fine?
I hope so.
So, hi everyone. Thank you for the opportunity to hold this presentation. My name is Hendrik and this is my colleague Tim. And we are from Dresden University of Applied Sciences. And we want to show you the IFC GeoRef checker. This is a little tool which we have developed at our university. And it's just a little tool which uses the IFC file, extract the georeferencing attributes just to check and also to update, for updating them. And there is a little concept behind it. And at first, before we show the tool, we want to present you the concept because I think it's necessary for understanding. Okay, these are our levels. So it's called level of georeferencing. It's not so academic, it's more a practical approach for georeferencing in IFC. Some things also Lars said before, which is latitude and longitude in IFC site and also the map conversion. So so we defined these 5 levels, and we said the more higher the LO-GeoRef is, thanks, the better is the georeferencing. So at first we have this level 10, it's just an address, which is the IFC and which is referenced by a building or IFC site object. You see here this UML diagram and also the representation in an IFC step file. So you have an address and this is referenced by IFC building or the IFC site. This is a short, roughly georeferencing for us. Then you have this level 20 and this is what Lars said, this standard for this IFC2 X3 data. So you have this latitude and longitude here, as he said before, and also the elevation. But as he said, it's only a rough point georeferencing. Then this level 30 and this level 40 is maybe a little bit difficult to understand because it's not mentioned in the standard of IFC, but it's our practical experience of IFC data, which we got from different companies or different test files we saw. And there's often the point that the georeferencing data here, projected coordinates, maybe a Gauss-Krüger system or a UDM coordinate, is stored as a Cartesian point and which is referenced through a local placement which applies to the IFC site at the object placement attribute directions with the axis. So the next one is a little bit similar, but it's not applied to the IFC site object, but to the IFC geometric representation context, and this is referenced by the IFC project. And you may know that every IFC file only contains one IFC project. So you have the coordinates here, and also a direction, which is the true north. And this is referenced by the context, and this one by the project. So, and level 50 is this this map conversion, which comes with IFC4. And in the map conversion, you can specify, as said before, the eastings, northings, the height, then also the rotation as abscissa and ordinate, and also a scale. And also metadata about the projected CRS. As you can see here, EPSG code and maybe some other information about the coordinate reference system. So then there's a proof of concept for this level 60. As also Lars said before, there is the problem when you have large objects, then you cannot use one scale for the project. And it's a proof of concept to say, okay, we add to the IFC file data about identical object points. It's common in surveying, maybe you know this, but it's only a proof of concept. So now I will come to the tool, which checks against these concepts which I described before. Okay, I have to switch to the So this is our graphical user interface, a simple tool interface, and yeah, you can set working directory. It's not so important now, but I don't have to do that because of that I know where the files are. Yeah, you can check IFC files. You can export a protocol and also a JSON file. The JSON is only for the we need it later for the building locator where you can place the building contour, and so this building locator will read the JSON file. I can show you afterwards. Okay, so I take some IFC files. I have this Savigliano from the benchmark, and also this Schependomlaan. I think you know it because it's a common test file, and also from the Netherlands, so I think you know it. So we can load it. It can last a while. Let's see. Okay, there are them. And now you have this check overview section. You see in the short result which levels are applied to the file. And you can also look in the log file what information was extracted from the IFC file. So here this region Roma in Italia, and also latitude and longitude. But for these other attributes, there were no global coordinates. So now you have the possibility to update the georeferencing if you want to do that. And there is the way manually. This is the window for the manual setup. You can use this if you know where your project point is in the coordinate reference system which should apply to the file. Maybe a UDM system or other national system which is applicable in your country. And we have also the possibility with geographic lib library from GitHub to do a conversion from latitude longitude to the UDM system, but it has to be the target system has to be an EDRS 89 UDM system because this formula behind it is for the UDM conversion. So it's not you cannot apply it to any other, maybe not to Gauss-Krüger or to any other national system. I don't know which system in your specific country is there, but in Germany, where we come from, you have this national system based on the universal transverse Mercator projection. So we can calculate this. Yeah, there's information about this, what I said before. Okay, it crashes, why it crashes. What I forgot. Oh, it's a typical situation, I think. Now it works. Maybe I forget something before. I don't know. Do you see it? No. Okay. Yeah. So you can calculate from the latitude longitude coordinate the coordinate in the UDM system, and you can also give them an EPSG code. I don't know, maybe it's not right yet now, but just for demonstration. This is a German UDM code. And now we can save it, and when I save it, it will write in JSON file with the information I write into the window. Yeah, it should be fine. And now I can export those updates from the file to the IFC. We write and read it again because we have those both ways. That's the reason why I have to save it and then to load it again, just for information. I open it, and now you have see it? Yeah, I think so. You have the possibilities to use the IFC map conversion for IFC4, and or if it's an IFC2x3 file, then it will be written as property set because IFC map conversion is only applicable for these IFC4 files. Or you can use this level 40. This means that you take the world coordinate system from the context and the true north as rotation. So I take the first one in this case, and now I export it. Should be fine. Okay. And just to show you that it was successful, hopefully, I open the file again, which I write out. And now you see this is true, and we can also look in the log file, and hopefully there are these attributes, and you see it, the easting, northing, it was null, I hope so, EBSG code, and also the rotation in a vector form, which IFC needs. Yes, that's our approach to write a map conversion to IFC, because we also know that Revit does not do this now, until now, I think. And so it's a little tool to help you in this case. So, and my colleague Tim will now show you the other way to update.
Yeah, as you could see, it's some kind of difficult if you don't know the exact numbers. So we also had an idea to make it via a map interface. Where here a map window will appear when the WMS server is ready, because it's a slow server, it takes some time to load the map image. But in the meantime, I can open the file. Here I can I choose the wrong file. Which one is the right? Here you can review the information that is already included. Now, since we want to specify in which projection we will save the new information, we can choose from a predefined list of available map projections that are supported by the WMS server, or we can use our own map server. If we have chosen the correct one, we go here and draw the building into the map. The bad thing is now that the default server is just bound to Germany. Since this building is in Italy, we can see it, but it's not in the closest zoom step. So if I zoom to the feature now, the map will disappear. But however, I can move it and rotate it to the correct place. Let's say it should be there. And another thing is level of georeferencing 10 defines an address for the building. That's why we can also query the actual address of the correctly located building, which the address is retrieved for this orange dot, which displays the local origin of the local building coordinate system. So if I query the address now, there is maybe no street. Oh, okay, there is. So it uses OpenStreetMap to retrieve the address data. And if I'm satisfied with my settings, I again have to save the settings, download the JSON file, and put it again into the checker application, which then can update the georef information. So that's what I already told, and I think that's it.
Yeah, it's also available on GitHub
Yeah.
if you're interested in, and
you surely will find some issues, so please help us and code a bit for making or improving our little tool. It would be very nice. Yeah.
Thank you.
Thank you.
Okay, so now there are any questions for them? Okay, so thank you. Maybe later. Claire,
We're back.
we try again.
We have a diagnosis, catastrophic charger failure. That's a good one. It could be worse. It could be the laptop. I'm happy. So I have a brick. It's working. Okay, so where we were, sorry about the interruption, everyone. Where we were was trying to import the Miran IFC file into Revit. I let that run, but I do want to show you the sorts of errors that you get when you're trying to do that. So IFC to... Yeah. I knew a live demo wasn't a good idea. IFC to IFC in a sense. So Revit exports IFC. I think Miran came out of Revit at some point.
Yes.
And try and import it into Revit 2020, and you get can't keep elements joined error, and you can look at the details if you wish to go through all 76 of them. But the easy, quick win just for this demonstration is to just unjoin them. While it's doing that, I just want to quickly show you what happens if you don't georeference your IFC and try and view it in various national projections. So this is the Miran IFC, put it through the FOE quick translator to create some shape files. This is what happens if you put it into British National Grid, so EPSG 27700, and this, we'll zoom out so you see where it is what happens if you put it into the Swedish National Reference System 3013. It dumps you, wait for it, into the middle of Africa, into Congo, exactly. Let's wait for OpenStreetMap to do its thing. So I've got an OpenStreetMap base map happening here. Zoom in a bit. Come on, you can do it. Oh, zoom to layer. Let's try again. Zoom to layer, just zoom out a bit, and we'll see where we are. There. Essentially, we are, for those of you who are good at geography, we are in West Africa. So, the importance of referencing your georeferencing your IFC files is there. There's an interesting reason for why the British National Grid puts it in Britain. That's because our 00 is not the equator, but more locally referenced. There's a long history behind that. We won't go into that now. So, second set of elements to the import in Revit. Again, just unjoin the elements is the easy way to do it because we're here to do georeferences. The third one says can't make cutouts. You don't really get much option to fix things. Delete it, and there you go. And give or take, I think the numbers are about right. 4 to 5 minutes later, you've got the IFC back into Revit, and you do get all the views, which is very good. So it's kind of very much a workable Revit file. I will just very quickly save that. Fix 2, and go on to the georeferencing. So there are 2 steps, more or less, to georeferencing. The first one, and again, this is fundamental if you want to get things right. If I just zoom in on the ungeoreferenced data and just do a quick measurement in Q, the distance across the site is 49 kilometers. Because GIS, or FME in its wisdom, thinks everything is in meters. But this is engineering data, so it's millimeters. So the first thing you need to do is to convert the unit in Revit before you export it into millimeters. And you do that by going Manage, Project Settings, where are they? Settings, Manage Settings, there we go. Project Units, which are as you can tell, I'm not a Revit user. So the easiest way to do it is to just change the length unit into meters and everything else. So it's quite clever. Everything else is changed accordingly. So that's the first thing to do. Otherwise, you get something completely off with the measurements. So far, so good. You have a number of settings for project location within Revit, and in fact, Lars's slides showed those as well. There's the general, so we're on the Manage tab for those of you who are Revit users. There's the general location option. And this is where you can type in a user-defined address of the specific site. One thing that we've come across, not with the Miran data, but with the Italy data that I was talking about this morning, that was created using a template created for Spain. So it automatically thought, because of the template, that the data was in Spain, not in Italy. So you really can't rely on the automatic location detection, not even in the country sense. If you've got a template for one country, it will think that's where you're working. So beware of that. This is, again, just rough approximation. You can, let's try London, for example. And it's thinking somewhere in Sweden. We've got 4 Londons in Sweden. And you can give it a very rough location there. So that's the first option. It depends on the geocoder inside that location box as to how accurate you're going to be. The second one, the more useful one, is the second option down on the menu. Hopefully you can see the mouse as well. You have a coordinates box, and there are 4 things there. Acquire, publish, specify coordinates at a point, and report shared coordinates. So acquire coordinates. This is where you can get coordinates from a linked project. So all the data we've been dealing with is single file. We've got IFC for one project, but obviously in bigger projects, and particularly in infrastructure projects, you might have 3, 4, 5, 6, 10, even different files that are then all linked together. So you can georeference one of them and link into it. The second one is publish. It's the reverse. I want to share the coordinates of this project with other projects, so you can publish it. Third one is specify coordinates at a point, and this is more or less good old georeferencing in the very old-fashioned GIS way, where you click somewhere and you tell it where it is in the world. Click and tell. If maybe there are a few of you remember a thing called rubber sheeting that we used to do in GIS, where we used to have a scanned image of a map and we used to say, this point is there, this point is there, this point is there, this point, and give it 5 or 6, and it used to stretch itself. So it's rubber sheeting, but it's simpler. And the fourth one is report shared coordinates, which is just click somewhere in the model and see the coordinates. So let's just do that. If I click there, you can just about see 57, 41, and elevation 147. Can you see that quite clearly there? So wherever I click, much as you would in the GIS, as you click around the model, you get different values. It doesn't do, it's quite thinking about it, and it doesn't do what a GIS does, which is when you move the mouse, the coordinates change with the mouse move, which would be quite a useful feature to have. And again, obviously, if you haven't changed your units yet to meters, you're going to get millimeters in this. But the boxes are very small, so you don't see that end unit. So something to be careful about. So, let's say the easy way. We've got, as Lars mentioned in his talk, we've got 3 tasks in a sense: a scale, a rotate, and a translate to georeference anything. We don't need to scale anything. It's in meters, it's engineering measurements, it's at the correct scale. We do need to rotate it, and we do need to move it, so translate it. So we can do that with the specify coordinates at a point option. What we have as well is, and I would just pop over to the slides to show you what we have in terms of the information. If you look at the left-hand side there, this is the information that we have for the original data. We have an elevation of 148, and then we've got some information. Let me find it actually there. There we go. On the website, sorry, we have original georeferencing details and georeferencing parameters for task 2. We can use these to scale, rotate, translate. Well, it's rotate and translate because we don't need to scale. So we can specify coordinates at a point, but what we need to do is decide where that point is. And there are, and actually I'll go back to the slides and show them to you, there are a few options. Where are they? Here we go. There are 2. Well, you can click on anywhere on the building. If you know the coordinates of a particular location, you could click anywhere and say this is that location, and it will translate. It will move the file for you, move the building for you. There are 2 sort of more formal options to do this in Revit, and this is set a base point, which is the 000 of the project coordinate system, and you can then set this 000 in the project, is this in the real world, or you can set a survey point, which is a real world coordinate system, real world coordinate near the building. And again, I think Lars described the difference between the 2 much better than I can. And the menu here is view, graphics, and visibility graphics. So we go on to view. Don't die on me. There we go. View, visibility graphics, and there's lots of things you can switch on and off. And if you scroll down to the site option, then you've got the project base point and the survey point. So you can tick them on. When you do that, you get the, if you wish, the anchor point for what you need. And you can then go back to manage, specify coordinates at a point. You can click on it. It's not a very precise way of doing things, but then you can type in the values that we have from the website. So essentially 145312, etc., etc., etc. The thing you can do as well in Revit is rotate as part of this process. So I'm going to just see if I can do this. Let's do it from here. 145312. 145. I think that's right, isn't it? 145312. I may be typing the numbers wrong. This is.
Yeah, I think you can.
6721 748. Anyway, you get the idea. And I think the rotation is something like 48 degrees. All right, so you do that. And that's basically reference that. You can check it again by just going report shared coordinates, and you can click again anywhere. And if you've done your job correctly, there you go, then you'll get the correct coordinates in the box. It's a way to check. Then what you do is you export it as IFC, and we've seen that a few times, so I won't, because it takes too much time, I won't do that. Export it as IFC, and a quick way to check that you've done everything correctly is just to use the FME Quick Translator. Now, this doesn't do anything with semantic maps. It doesn't do anything more than just convert the formats. You take the IFC in, you tell it which national coordinate system you've said you're going to use, which is the Swedish one, 3013, and you put it out as shapefile or as whatever other geospatial format that you actually want, and the coordinate system is the same as the source, and you let that run, and that will generate, again, just in the interest of time, Dropbox, Sweden data, let's see, Sweden data, a whole bunch of shapefiles, literally one for each IFC class that you've got in your model. So you get a whole bunch of shapefiles. Like I said, this does not do any semantic mapping, but it is interesting. I find if you're trying to learn a little bit about how IFC works in general, and also to check things have been modeled correctly, because you can visualize them. So then what you can do, obviously you've got shapefiles, you can put them into QGIS, and in QGIS they appear like this. I'm going to zoom in just to show you something about geometric complexity. That lovely lot of little triangles, somebody was saying about floor plans earlier, is just one multi-polygon in the IFC site surface. It's one row, one polygon. Look at all the geometric complexity for what is essentially 1, 2, 3, 4, 5, a five-sided object. So there is a conversion issue in terms of adding, I suppose, additional nodes. It's not even a 3D surface or anything, it's actually quite 2D. But you basically get the data into your GIS, and you can then check, and it turns out Miran is in the middle of some lovely green forest or country park, so there's no buildings that we can show you, but you can then check it's correctly. I'll zoom out enough. Swedish people, is that Sweden? You have to zoom quite far out. You can tell the scale difference as well. There you go. So then that's correctly geographic. So it's quite a simple way of doing things. There are probably better and more sophisticated ways, but again, it's a quick and easy way to get the georeference BIM out of Revit and into GIS. That's a way to check. I think that's good. Yes. yeah, just one final thing off the slides, and we're good to go. Just to show you the difference inside the IFC file of the georeferenced and the non-georeferenced. So there you go, just to see the difference of what IFC site does. It looks further up the file for the actual coordinate values. So, final concluding remark, you don't need to do this in Revit. We've seen a number of options today as well. Abdu Diakite formerly from TU Delft, but now University of New South Wales, has written a paper on this, and you can find it there. And Sean Morris, who's at the back from Esri, has also been showing us some interesting demos of the Esri tools that you might want to have a look at and check with him about.
Thank you, Claire. Okay, we are a little late, but if you agree, we can move forward 10 minutes our coffee break and listen still to the other demonstration. Or we can go to coffee break and then having it. Shall we rotate? Who wants to go for coffee? Very shy.
It's a cluster. It's up in front.
Who wants to see the presentation? Okay, I decide. So go for coffee break and see here in at 2:30. We begin with the other demonstration. Okay.
So
about the referencing.
Discuss any.
No, I will check that. Did you save it? Now it's on? Okay, so now Jeffrey?
Your name.
Your name?
Yeah, it's very hard to spell. I'm not even trying now. When I was younger, I was trying before.
Okay, so your name will show us the procedure you used for georeferencing within FME. So please take a seat and we can move forward and see his presentation. So thank you, Yarnay.
Okay. Maybe wait a few seconds.
Okay, Yarnay is about to begin.
Okay, so maybe for FMA was mentioned quite many times today and also yesterday. Is there, how many of you don't know FMA? Maybe just to start. Okay, not many. Okay, but for starters, let's explain it. So it's called feature manipulation engine. It's used for manipulating spatial data because it has a really strong support for spatial data. I really like they are calling the FMA, the safe software, sometimes as a Swiss Army knife for spatial data. I really like this term because it really represents what it can do. And it can also be represented like this picture. So it offers a thick pipe type of transformation. So you can really do a lot of transformations of your data during the translation. So the power of FME is in those numbers. It can read and write 350 plus formats and offers 450 plus transformers to transform your data that you use. And you can say it's not a typical program like others that were included in the benchmarking because, yeah, it works different. It enables things to be done in very different ways. It's like putting Legos together sometimes. Okay, if we ask yourself, the FMA supports IFC data reading and writing, so that's covered. And it also supports transformations of any kind, so it has extensive support for spatial data manipulation with all kinds of transformations. So both things are basically covered, and it should be a straightforward task. So just read IFC, transform the geometries, and write the georeferenced IFC. But it's not so easy. That took me just to basically build the translation. Took me 10 minutes, and of course, it didn't work. So what's the problem? You can extract data, you can transform it, you can write it, but the data you write it is not the same as the data you read. Because the IFC is so complex that FME that extracts the data is not able to extract all the complexities of the IFC, original IFC data. And I failed at those attempts to transform it and everything, and then I end up just, okay, can I just copy the data? So just to read it and write it, just without any modifications. And I failed again. So this thing, like just reading some specific things that was mentioned yesterday and also today, that can be really useful because we don't need everything from IFC. Many times we just need some classes, some things, and for that I think FME can be really useful. You can select what you would like from IFC. You can scale it, you can rotate it, you can offset it. You can also use other transformers that are more, let's say, to do the geographic transformation, not only offset it, and write it to, let's say, OBJ, KML, also CTGML is supported. So it can be used that way, but not to write back an IFC file. That's a no-go. But I thought, okay, FME is so powerful, we can also try to do it a dirty way, not really with IFC reader, but I tried it with a text file reader. It is, at the end, it is a text file, so this is, let's say this is an IFC, so it can be read like a text. So that partly worked. It is similar to what Henrik does, and it's nothing special, but it reads the whole text, and one line is one feature. And then you just end up parsing the text in each line, and you find the, let's say, I tried with the level of georeferencing that Henrik mentioned, the 30. So georeferencing using IFC site placement, and it worked. And I got the full IFC back that was georeferenced using FME. So we cannot really say that it doesn't support it, the georeferencing, but it is quite a dirty way to do it. But it can do it. So we did that, and we were successful. So it was georeferenced. Here is also a diagram how it is done. So it's done in more steps. So first you find IFC site, then local placement, then axis placement, and then there's a problem if the IFC Cartesian point and IFC directions links are defined. If they are no, you create them, and if they are, then you change them, and then you end up with a georeferenced file. So now I can shortly just show. I'll go to my computer now. Okay, so this is the basic workflow just for copying, and the problem is also that, yeah, the file was not the same, but this is not the only problem. You see, if I zoom in here to the IFC door, let's say, and you see that I extracted 62 doors. But when I open the IFC door of the written IFC document, I end up with having 77 doors. I don't know why. They just some of them just multiplied, and then I just stopped. Okay. But they look okay, but some of the features that just explode. Okay, so that obviously with readers and writers to copy the file and use the transformers, that doesn't work. Then there's an option, okay, to use scaler, rotator, and offsetter, so to manipulate the data, and then also writing to IFC failed. But if you want to use that data for other purposes, just writing to maybe georeferenced shape file that was mentioned before, that works. And also this mentioned before, the workspace for the dirty workspace. So it's like this. You find the IFC space, you split the attributes. So this string that contains all the references, it's like this. Okay, where I have it here. So you split this string into attributes and then extract this one, and with this reference you find this one, and then you parse this string and find this one, and just cascade to this element and then correct it manually, and then just write it as a text file back. And it is, at the end, it looks like this. Many connections, because there are more options about if there are these values, these ones, if they are set or if they are not set. Then you have to create them or change them. So that's why there are so many options here. But otherwise, it works. Okay. This is quickly by me.
Thank you, Yarnay. Yeah, I also forgot previous ones.
Any question?
Is there any question for Jeremy? I also forgot previous ones. So. Can you ask? Thank you very much for your presentation. So, okay. Now we go to the last part of the workflow with conversions, and Nebras will tell us about it. So please, Nebras, to you.
Thank you everybody for surviving with us until the last session. My presentation is about the last task from the workbench, which is the options for conversion from IFC to CityGML and CityGML to IFC. I was asked to give it, but it's actually your work. It's the work of participants, what they did to perform this conversion. So I would like to ask a question: who here performed any task, any conversions from this task, task 4? Nobody? Yeah, we have one. Great. Nice. So we have 15 participants, and we have one here. So great to have you. The presentation outline will start by talking about the task itself, and I will talk about the results template in which the participants filled the results. I will quickly go over the data the participants applied the results on, and then overview of the submissions and observations from these submissions, and the most important part is the discussion, so we can have a discussion about what have you noticed during this kind of conversions. But I thought let's start by wondering why we convert the data, and I just came up with 3 very quick useful ways to use them. So, for example, we can update the CityGML data using BIM files to keep it up to date, as mentioned before a lot in the presentations. Other useful way is to give context to BIM projects within BIM integration, which is the idea of the whole day. In the task, the participants applied an IFC to CityGML conversion and CityGML to IFC conversion on the provided data, and then they provided the description of the workflow, including all the steps and the settings they used. And then the results are submitted, the files and the template, the result templates is filled. The first section was the participant information in the results form. The second section is the tested software or tool. The third section is the computer hardware that was used. The fourth is the task itself. So what was the performed conversion and how it was performed. And the last section was finalization, where the participants said their final comments and they agreed to actually provide us with this data. So the participants actually tested on this IFC data. You all seen it multiple times a day, but very quickly it's Uptown and Miran and Sadiq Liano, which are created using Revit. And then we have 2 geometry files. The first one is in IFC 2x3, and the other one is IFC 4. And these one were created by using IFC OpenShell 6. These data files are the participants converted them into CityGML and then provided us with the results. For the opposite conversion, from CityGML to IFC, the participants used these 3 data sets. You also know all of them. The first one is Amsterdam, which is level of detail 1 data set, and it is generated using a 3D file. Rotterdam is created by Gemeente Rotterdam, and it has 2 levels of details in the same file. It's level of detail 1 and 2. And buildings are a level of detail 3 data set, which is procedurally generated. And again, the participant converted this CityGML data to IFC4. So we received some submissions. These are the pretty new submissions, I would say. So also the results and observations are quite rough for now, and maybe for later we can have more concrete ones. But the submissions came from 15 participants, and in general they submitted 43 form, because for every data set you need to submit different form. Understandably, most of the participants submitted to the conversion from IFC to CityGML, while the conversion from CityGML to IFC is actually done by or tested by 2 software. I guess the reason is because there's more research and more tools are already developed for the IFC to CityGML conversion, because there's more demand for that one. While from CityGML to IFC, there's less demand, so there's less tools, and maybe even the participants were less interested in that one. The softwares that were tested are FME. In FME, some participants used the FME Workbench, so FME Desktop, or FME Quick Translator, which means that it reads the file and simply write it in the desired format. It's very simple too. FZK Viewer was used in both sites, so for both sides of conversion. And ArcGIS Pro with the data interoperability extension was used by some participants. There's also one bespoke software, is IFC CityGML. It's a non-commercial software. Firstly, my first observation was that there was always problems with the conversion, especially from IFC to CityGML. It was never perfect. Always problems with the geometry, or the semantics, or the structure of the file. The results are, understandably, it was described by the participants mostly as level of detail 4, because as we know, IFC is high detail, it has high detailed models, so you expect a high detailed CityGML file. Now I will talk about the observation from the comments of the participants themselves. So for the IFC to CityGML tool, there was, of course, the conversion was done, but in this presentation I will talk only about the issues. So there was some elements that was lost during the conversion. So roofs are missing. There is some surfaces was inverted in the results, and it's a observation by the participant that the missing elements are mainly IFC closed shell, IFC closed shell geometry, and the suggestion was to add IFC spaces to get an improved results. For FME Quick Translator, the files are all converted to generic city objects. Some floor are converted, while adjacent ones are not, and roof and window features are missing after the transformation. Different softwares dealt with conversion, with the converted files in different ways. So FME Data Inspector didn't show any geometry, while FZK Viewer was able to do so. And many geometries are not transformed. It's possibly because the solids were too complex, or not closed, or not orientable, or they are missing some traits or appearance or measuring attributes. Again, for FME desktop, when the IFC file was opened, it didn't support some solids. So these solids logically was not converted into CityGML. The resulting files are described as the level of detail 2 by the participants. and so the roof and the window features are missing after the transformation. Again, the visualization was different among softwares. FZK Viewer, based on my own experience as well, it has high tolerance for errors. So if there's if the files are not according to the standards correctly, still the viewer will be able to read it. So it can ignore errors. A lot of geometries are not transformed, again, maybe because the geometries are too complex, non-orientable, or missing some information. Some topological relations are missing also between glass windows and steel frames. Maybe by using corrected or cleaned geofencing, or volumetric or surface property for the entities, the results can be improved. By using ArcGIS Pro, I didn't receive many information about this conversion, but it also was not perfect. It has some mistakes. For example, IFC poly clipping result was missing. And the results were described at LOD 3 and 4 by the participant. So for the opposite conversion from CityGML to IFC, we received two submissions for the two softwares. The first one is FZK Viewer, which was able to convert the data correctly, but when the level of detail 1 and 2 existed in the same data set, so for example in Rotterdam, then there was the exported file was not, the BIM softwares were not able to read the resulting BIM files. So we can simply fix this issue by exporting each level of detail separately, and I think it will work fine. But also minor error, but you just need to manually add the .ifc file to the IFC4 dataset. Using FME Quick Translator, the results was described as level of detail, level of development 200, which requires more discussion actually maybe after the presentation. And the results were an empty hierarchy with no semantics or geometrical information, beside the top hierarchical information. So the participant tested the quick translator on different data sets, and he received the same results. So basically, FME quick translator didn't work for CityGML to IFC conversion. So some preliminary analysis. Every software created different outputs. Yeah, the results were mainly in level of detail 4. This is for CityGML. And there's limited support in GIS actually for level of detail 4 data. FME processed the data, but a lot of time it has empty or invalid geometries. While ArcGIS, for example, exported only geometries with missing data. My observation was that FZK Viewer for conversion from CityGML to IFC was the most complete one. And maybe some points for discussion. The idea is that if there's no ground truth, then how can we say this is correct or this is wrong? Because there's no software that performs perfect conversion that we can compare with it. Another point of discussion is that we have resulting IFC files or BIM models, and these are described by level of development, which, correct me if I'm wrong, but it's actually level of detail plus level of information. So how can we actually maybe measure all these factors, or how can we describe level of development? And most importantly, this is not an absolute conclusions. So it's just patterns and evidence to reason on. I'm really depending on the participants to maybe give some feedback, and maybe it's time for discussion now.
Yeah, thank you, Navrat.
Thank you.
Do you have any questions? Yes.
I have a question. I saw that you concluded that ArcGIS Pro with data interop extension gave better results on geometry than FME did.
Yes.
But basically, data interop extension is FME.
Yeah.
So probably if FME performs less good than data interop,
That doesn't make sense.
somebody didn't know how to configure FME.
Indeed.
Or, yeah.
Indeed. So this is not my result, of course. This is the result of the participants themselves. But I think the person who tested FME, I hope he was here with us now. I think he used the reader and the writer. It didn't use transformation, which probably is running in the back side of the ArcGIS Pro.
Yeah.
That's my guess, but I don't know.
Yeah, the results have to be further analyzed, and also we should consider, as also Lars was saying before, the level of expertise of the participants to understand also nuances and issues. Other questions? Yes? Lars?
I guess that the model, how they are built up, is also affecting this. Do you see any difference between the models?
Well, the data sets themselves.
Yeah, I mean, if you, for example, if you write an FME script, you often tailor the FME script for a specific model. If the structure of the model will affect your result, and there is no standardized structure.
Yeah.
So my question is, perhaps that different people here, but do you think that the participants say anything about the different result of the different models between how the models were structured?
Yeah, okay, I understood the question, like if how the different models are converted and if they are in the same way. So these are really initial results, and we just went through them and analyzed like common patterns and common comments from participants. And in next month we will analyze them much better, considering all of these. So it's something, of course, to be considered, and we will. But next time presentation. Sorry for this. For the moment, we still don't know. Yes, Anya.
Project, and we use the also converted this device, but during the project we of course also thought about using constructions in IFC that are not in the NVD, so you usually don't find these things necessarily in IFC, but it would be good to have that if you want to get proper CTGNL files, and we consider to create a custom MVD that describes what you want to see in IFC file if you want to make a conversion. So a geo MVD if you want. So that would be the possible solution to the problem that you have. Of course, the content of the IFC file and instructions that you usually get from that.
Yes, I think so. I think it's a very good idea. Yeah, and this has to do a little bit with the first part of the discussion that Nebras was underlining. So with the ground truth that we should consider for understanding if the conversion was good or not good. So because one thing that we noticed while analyzing all these produced models, so all the converted models, was that they're all different one from the others. So maybe not wrong, but is it a wall standard case, adjust a building element, or something else? So in next step we have to find a ground truth, and this is of course something that that could help to have a model definition that exactly says what is needed for the conversion. Do you have any other ideas for this point? And the one that I care most, that I like most, is this one. So we have level of detail in CDGML, level of development, level of detail again in the ISC, level of information. So just tell me, how can we map one from the other? What is the correct way to do it? Yeah.
Well, I think they fixed the issue of GML being all over the place in the structure with JSON, right? By flattening GML to JSON,
Yeah.
they fixed the structure where it's when converting, you're unable to find the right parameters, values, because the structure of GML is really diverse. It's what Ballas
Yeah.
told us. So maybe if you convert the GML to JSON and then convert it to IFC, maybe that has better results with missing geometry.
Yeah, but like the flattening was about removing some details, some of the details that are redundant and too complex in CDGML, but like the geometry is still 3D, and we like the definition of Philip Liek in his PhD thesis of LOD 1.1.2, so just a rectangle or the rectangle with all the edges, all the different parts of the buildings, and even for the heights. So this is something that is still articulated in the city model, but for the ISC, is it still different? So maybe someone more in BIM can help me. Like, is the level of detail the same than CityGML one in BIM? Yes.
They are very detailed, and that's of development is one part. But if you have, I think I did much earlier in the development process, sometimes the early design only considers the mass model, which is basically the outer shell that you might want to reuse later on for lower LOD model, but usually that's thrown away. So that would be an idea to keep these representations also on the information modeling side.
Okay, so that should, I think that should something to be further explored now, how to, what is the more suitable level of development or detail or information that I discovered from very recent times in BIM to be converted in CDGML, and also if we convert a CDGML, which is in a certain level of detail, to BIM, what do we obtain actually? So okay, so that's something I guess is still open, and yeah, and I think that for the moment is what we have. Do you have any other questions or suggestions? Yes.
On slide 18, there is a whole list of issues that you encountered, and there's also LOB2. What do you mean by that?
Yeah, the results are described by the participant as an LOD2. That's what I mean.
So the issues are encountered when with the LOB2 dataset.
No, it was just an observation. It's just part of the results.
Yeah, so this is the participant described the results as a level of detail too. I think it's not fully correct. Yeah.
Okay, thank you, Navras. So
maybe I failed to say something. I will continue the next the presentation with the tool that I developed actually to convert CityGML to IFC. So maybe it will answer some questions, because the question about parsing the CityGML file is going to come up with the next presentation.
okay, so I leave you for the next presentation.
Yeah. So for my master thesis, I developed a tool. I called it CityGML to IFC. And it performs, as the title says, automatic conversion of CityGML to IFC. The idea is that both formats has a lot in common. They are 3D models, but they differ in the focus. So the IFC files are more detailed representations of the physical buildings, while CityGML is abstractions of the real world. So in this presentation, I will talk about how I convert CityGML to IFC. And I will start by talking about the motivation for this research, the methodology that I followed, and what are some conclusions of it. So the idea is that 3D city models are currently not accessible for the architects and engineers within their software. So the idea is to be able to import this data into the BIM software of choice. For example, if a company wants to build a building on an empty lot, then they can go to the CityGML data and then select a group of buildings that's surrounding the lot, and then import it as IFC. And then by importing it as IFC, they can then use it in their Revit software, and then they can start developing within the context of the project. Here is for example, the 3D model for Rotterdam, and then we can imagine selecting a couple of buildings, and currently the model allows us to export in different formats. So, for example, SketchUp format or the DWG for AutoCAD. But maybe we can embed an IFC format within the process. So after exporting, we can import it into our Revit software, and then we can start designing within the context. To provide a methodology for this conversion, I talk about 5 main requirements that we need to look into. These are the semantics, the geometry, the coordinates, the topology, and the encoding of the 2 formats. First, theoretically, I compare between the 2, and then I convert from CityGML to the other. So how to convert it in theory and in actually encoding, so using Python. So the methodology starts with defining these requirements, and then describing them theoretically, comparing between the 2, and then providing theoretical conversion, and then all this theoretical conversion I combine in one basic Python implementation, and then I develop this implementation by testing it on different data sets to get the complete implementation that can convert basic implementation on different softwares, and I debug the implementation to get a complete implementation. And lastly, I study how can I make it accessible for the users and provide some conclusions. The complete implementation, I call it CityGML to IFC, and it's available on GitHub. You can access it and simply download it. There's information how you can apply it, and some sample data set I provide with in the GitHub file. The first step, of course, for this kind of conversion is, or the biggest obstacle, is to convert from the first encoding format to the other. So CityGML, as you all know, is based on XML, and it's in a hierarchy that reaches down to the elements, while IFC has an express relation between the element, and it's a step format. So what the software do is it reads every line or every feature in CityGML and write it in one line in an IFC and create this express relation between the objects. After getting over the encoding obstacle, then we can look into the other elements. So for this, the geometry, the CityGML files have simple geometry, which is basically 2D surfaces. But an IFC has multiple options and more details for the geometry, so we can get 2D faces, solid, CSG, or others. So we need to know from the source the geometry, what kind of resulting geometry we require actually. the geometry and the main difference in the geometry between the two standards is that IFC has the geometry separated from the semantics, while in CGML it's embedded within the semantics. This is the IFC example of IFC geometric representation. So semantics and geometric representation are totally separated. So for example, to convert the geometry from CGML, I extract the points from the every position or point list in CGML, and then I create IFC Cartesian point objects in IFC, and then I create the geometric representation, which is then attached to the required semantic. This is just a small note that you need to convert from 5 to 4 points. And I remember it because, for example, in FZK viewer, if you make a mistake and you write 5 points, it's fine. It will be visual. You can read it. But in other software, it will report error, and then you need to fix this according to the standard, and then it will work. So this is just a simple example of kind of mistakes that some software can actually ignore and continue. After the encoding and the geometry, I look into the georeferencing because, of course, it's directly related to the geometry itself. So CityGML files are globally referenced, as talked about today a lot actually in the coordinates conversion presentations. And in the data sets that I use are from Rotterdam, so it's the Netherlands, where all the points are referenced to the Amersfoort georeferencing system, which has a Cartesian value, so it's meters and so forth. On the other hand, IFC files are locally referenced, so there's one reference point that all the points in the project is referenced to this reference point. Again, it's already talked about today. So, for example, the way I convert it is that I take every object, and then, which, as you see here, it has very high values because it's globally referenced. Then I take the minimum point in this in the project. I extract the value of this point, and I subtract all the points in the project. Extract its value from all the points on the project, so I get like smaller values for the points in the IFC file. And then this point is considered a reference point, and its value is then converted to WGS 84 and stored in the IFC site class. So that the resulting IFC files will be somehow georeferenced, but as we learned today, it's not totally detailed, because what I convert to is IFC 2x3, while in IFC 4 now we can have more accurate georeferencing to the files. The next thing I look into is the semantics. So because CityGML is it's usually more updated data about the city, and it's just an abstraction of the elements. So the number of the classes actually is much less, while IFC has a much higher number of classes, and this actually creates the question is, if we are converting from CityGML to IFC, then we have multiple options of classes that we can convert into. And I find it easier then, so we can in CityGML we know the standard, it's a fixed file, and then we can choose a destination semantic and we convert to. And I think this is why a lot of the softwares are struggling to convert from the other side, because IFC has a lot of detail and it's so complex that it's hard to anticipate what kind of file you're going to receive and how can you generate a correct CityGML file from this file. So what I did basically, because my work is CityGML to IFC, is mapping the CityGML to the CityGML semantics to the classes of choice in IFC. I perform the conversion of them. Lastly, I look into the topology, because again, sometimes when you convert and you have some mistakes in in the standard, some software will read it. So for example, when I first converted, I was able to read the files in FZK Viewer. But then when I tested with other softwares, there was some error messages, and it was actually resulting of missing topology. And in topology, in my context, I mean is, for example, if that group of walls and slabs belongs to a room, and this room belongs to a window, and this kind of hierarchy. This is the topological relations that I mean in this context. So basically, I extract this topological relations from CityGML and create them in IFC. And CityGML, these topological relations are fixed, as you see in this example. So this is the relation between opening and building in CityGML and the fixed structure. So opening exists in a window, and the window will exist in a wall surface, and the wall surface in a room, and the room exists in a building. While in IFC, the location of this topological structure can change because, again, IFC is more flexible than CityGML. So IFC space position can change in this topological structure. And in this example, IFC building story is a part of IFC space, while in the other example here, it's IFC space is a part of IFC building story. Both make sense, actually. So to create correct IFC files, I create necessary topological relations. And then I get a basic implementation and that I tested on different software. So FZK Viewer is very tolerant. So when I first converted the files, I was happy and excited that the files worked. But then when I tested with other software, the computer didn't show anything. So I needed to test on different softwares. And as mentioned before, there are some softwares provide us with the error log, which helped me to create like a validation process. So at first, if it shows in FZK Viewer, then it's great. I move to the next step. I test with other viewers, and then with other BIM softwares. And based on these error reports, I fix the code to get more according to the standard and according to my needs software. And then I check with the users if they can also visualize and use the files. As a result, the resulting files were able to be read by all the softwares that I tested. And for example, in the BIM modeling softwares like Revit, you can even edit the files, add to them, and remove and start designing as we want from this kind of resulting files. So as a result, we have complete open conversion methodology from CityGML to IFC. It's simply written in Python, so it's you can easily read and expand on. This Python code can convert the semantics from the CityGML to IFC and extract the geometrical resource and store it in an IFC file, and create a georeferencing to the IFC file and store them and convert them to be correctly referenced in the class IFC site. This conversion can, as you see here, it's mainly for the level of detail to CityGML files. And it's because it's open and it's a simple piece of software, so you can maybe embed it in a visualizing tool or in an FME server, so it can work in the background and provide the user with an IFC converted file for CityGML. It can be further extended. So for me, I convert some classes, but maybe we can later on expand it to be able to include more semantics, or maybe to become able to convert to IC4 actually, and so forth. So it's easily expandable. And small observation from the work is that indeed IFC is complex, but it's also flexible, so we can convert multiple ways and it's fine. And therefore we can convert in different elements. For example, instead of generating 2D faces in IFC, maybe we can create Swift Solid, and we have like solid representation of the walls. Also for bytes. So for me, pipes for me is converted into generic city objects. but then it can also be converted into Sword solid, so we can easily generate topological relations between objects. Thank you for listening, and if you have any questions, please.
Thank you. Any questions? Lars?
Interesting. How do you decide which geometry?
Which geometry?
Geometry type to use in IFC? I'm not sure if you should use that solid or CSV.
Yeah.
You have to make a choice. But how is that choice?
So what I did basically is I convert all the 2D faces from CDGML directly to 2D faces in IFC. And because IFC is flexible, so in the definition it says, for example, a wall can be 2D face, or it can be subsolid, and it can be so forth. So for me, I all converted to 2D face because it's the most logical one. As mentioned in the last slide, in some applications, it makes sense to convert into Swift solid because you need to create topological relations, for example, for pipes, which maybe this is for future work.
Questions? Yeah.
Which license do you provide this program for?
It's open for use. So I provide license, but it's available for people to expand and use develop on as long as they mention, of course, the referencing. That's it.
Yes, I noticed that the project is on more GitHub accounts, whereas some of the other tools you see are actually like from team jobs.
Yeah.
Will this one also?
Because I was a student, so it's.
But will it be maintained by the university as the other ones, or?
No, I think it's just my GitHub. It's just a personal account, and it's not maintained by the development.
Yeah. Yes, I'm not sure if we redirect to our website to the thesis. I'm asking Stadios if he knows better. No, not to maintain, but at least to redirect to his GitHub maybe. I don't know. But, yeah, that was my reading. Anything else? Okay, if there are no other questions for Nedras, thank you, Nedras.
Thank you
And,
for listening.
Thank you. And Helga, would you like to come? So for the last demonstration of today, Helga will show us how his their software for conversions work. So
This was the long title of the Singaporean IFC to City GML project. I don't want to tell much about the background, but show this small 3-minute video which provides an also a little demonstration, and then the main part was the conversion. You will see a little bit around the conversion actually, and then after that I'll show you the small tools that we've developed and how they look like. So. That was a quick overview which showed this loop that we did. So we went from the use cases, derived City GML requirements, also developed an ADE for that, and then back to the IFC requirements, the requirements that you have on the native BIM, where we can derive modeling guidelines from, and then the actual data conversion goes from IFC from the native BIM through the export. We looked at the export options. Then the conversion. I wanted to switch this page to something that's why it was smaller before. Bit smaller so you can see. See better. So the first thing we have is this is a rule database, which contains rules for different conversion configurations. So you can, so this whole process, the conversion process, is configurable without hard coding. You need to hard code the rules. So this rule database now should run here. And so we have set of different rule sets. So the rules are grouped in rule sets for different purposes. We made a lot of them for experimentation. So I want to show the one. Also, we created like modules of different rules that convert specific parts of the, so they cover specific parts of the conversion. For instance, this one, this is the rule which converts a face in IFC to polygon in CityGML. We developed a custom domain-specific language to describe these rules. And then there's also a visual representation of this graph transformation rule. You can imagine, so in this case, this rule expects face and connected face set on the IFC side to be already converted and to be there, and connected GML shell already there on the CityGML side to be converted, and then it adds this polygon. And it's just an example of the rule. And then we have this rule set, for instance, is one that we used for demonstration, which contains rules for converting the geometry, rules to convert different property sets, also to populate the elements of our attributes of our ADE, and to build the spatial semantic structure. And then from these rule sets, that's what you saw in the video also, we derive a specific payload for the conversion. So it's JSON. Yeah, it's JSON, which is then consumed by the conversion tool to configure the actual conversion. And I want to show you how that is done. So we keep our IFC files in BIM server and fetch them from there. So I start up this BIM server, and while this is starting, I can already open this conversion tool. So this is the conversion tool. If it comes up, it has a little graphical user interface, which does not much, but also command line interface, because not many parameters that we need. So essentially, this tool fetches a specified IFC file from the server and a specified rule set, and then creates the GML according to these two inputs. And if you see that the BIM server is running, should be, then I put some of the files here. For instance, this is the IFC geometry file, and that should now be, we select that connection, so that there's some configuration for the connection which contains the URL of the BIM server and the credentials, and also now it knows it has connected. It finds the same 3 projects, and in this IFC geometries project, we have 1 revision. If we would have more, we could choose the revision here of the file that we want to use. And then we have the rule sets. So if you use the command line interface, there's you can also fetch this JSON, of course, directly from the rule database. But here is basically that JSON that was created by the rule database, but saved in a file and then read from that file. And then, you also have to say where you wanna put that. Here. And then it doesn't tell you when it's ready. That's a bit weird. But you can see the output here, the log output. So it issues some warnings because there are missing arguments for the rules. So some values that are not there in the IFC, and then it says that it's ready. I don't have a viewer here, but we can look at that file and see that there's a triangulated geometry. And yeah, that's basically it. And so maybe also the so if you want to run that from the command line, then it's just specifying the same parameters, connection information, which configuration to use from that, which project ID and which revision to fetch from BIM server, and which rules set to use and where to put that file. And then it should. It does exactly the same. Hopefully. That's how long it takes to fetch the model from BIM server. A bit quicker than the other one. Also, the whole conversion is a bit quicker than the command line. Yeah.
Thank you. Any questions for Elga?
Before I switch it off.
Yes, one question. Say this.
So I try to understand the rule sets are the rules for mapping, one classic from IFC to GeoBIM, is that correct?
Yes, if you want to. So the theory behind it, I didn't tell much about it. I wanted to. The theory behind is that we use graph transformation rules, and they, in theory, these rules if you specify them as a grammar, they specify the whole set of consistently connected IFC and CityGML files in the graph grammar. So that's the theory, and then from that grammar you can infer or create forward and backward transformation rules, and you can also infer synchronization rules or update rules for connected models. But what we did here is we directly specified the forward transformation rules only. So in next steps, I also want to look at the more general applicability, and then do something similar, like you also look at to use the same rules for forward and backward transform. Not exactly the same. There will be some some parts that are different, but yeah.
Can they use the rules for also generalizing some
No, we didn't tackle that, but we have so the rules, they can have some so you can predefine converters which are compiled and then executed on conversion. So, and you could if you have a generalization algorithm implemented that way, you can integrate that in this approach as well. But the rules themselves are not sufficient for that.
Thank you. Any other question? Okay, so we are at the end. Okay, so we arrived at the end of this workshop, and it was very interesting. There was a lot of interesting discussions and topics presented, and a lot of contribution for you. And I hope you enjoyed. I want to thank you, to say thank you to a lot of people, also to Ken, who is not present, but present by remote, to all the 3D information group, to the speakers, to the benchmark team, the participants, to the AMS staff, Carolina and the others that were very helpful in the in setting up of everything. And also to all of you, it was very nice to have such a varied audience with people from academias, from companies, and from municipalities and so on. So thank you very much for participating and for giving your support. So we are at the end. What's next? Like, when preparing my introduction, I was playing around with Google Trends for understanding if there was something interesting, and there was nothing interesting, except except for these falls, which are actually the holiday period for Christmas. So I took it as a sign, and I will say Christmas holidays without BIM will be the next. I hope that it will be the same for you. And but good purpose for 2020, let's integrate your information with BIM. So now we have a good base for doing it. Goodbye to everyone. We will publish the workshop materials, so slides and the recordings of the workshop on the website, and also any other outcomes from the benchmark itself on the benchmark website. And for any other questions, we are there for answering by emails and stuff. So goodbye, and thank you very much for